All right, good afternoon, everyone. Welcome to the Bokeh tutorial here at PyData San Francisco 2016. Hope everyone's had a really useful, good, exciting day here at the first day of PyData, the tutorials. Just coming down the home stretch, I think we've got the last tutorial sort of series going on right now. So today, I'm here to talk about Bokeh, which is a library for data visualization from Python, from other languages in modern browsers. And so we'll be going over sort of some basics, but really today the focus is going to be covering some of the more sophisticated data application interaction kind of capabilities that Bokeh affords. So anyway, my name's Bryan I work for Continuum Analytics. I'm very happy to be here. I'm normally in Austin, Texas, but very happy to come out to PyData to be here today. You can reach me at BigRedDot if you care to tweet at me. Anyway, so just a quick overview of what we'll go over today. I only have a couple of slides. Typically I have a very hands-on kind of tutorial, so hope everyone's ready to do a little bit of coding or pair coding with your neighbor. Well, it's a complete wrong order. Let's just bring them all up. Sorry about that. Last minute slides. So the first thing is just sort of an overview of what Bokeh is and you know, also what we'll be covering. The tutorial has actually grown quite a bit in size in the last 6 months or so. It's a series of Jupyter notebooks. We don't have nearly enough time to go over all of it, so we're just sort of going to pick and choose today, and we'll see what we have time for. But anyway, I'll go over that in just a second. I also wanted to do just a couple of demos, both of things that we'll be talking about, but also some of the upcoming features. So Bokeh has been under heavy development for a couple of years now, and we're really sort of rounding things out and heading towards sort of a 1.0 release, hopefully in the next few months. So I at least want to give maybe a preview of some fun things that are coming up. Then we'll spend a little bit of time just for installation and setup, make sure everyone's ready to go, has everything installed that they need to have installed in order to work the exercises. And then in terms of the chapters for the tutorial, I am going to start sort of fairly basic with the sort of Bokeh.Plotting API, sort of go over that section a little bit, but then we're going to move into some more sophisticated things involving layouts and widgets and interactions that you can add in standalone documents, and then we'll move on to what you can do with the Bokeh server in terms of hosting really sophisticated applications using Bokeh. And then finally, hopefully, we'll have some time at the end for questions as well. So first thing, actually, we'll have some more detailed installation instructions, I guess, in a notebook in a minute, but you can use Condo or pip to install Bokeh however you like. Probably also want to install the Jupyter notebook, so conda install notebook, or I think pip install IPython brackets notebook will also work. But the main thing is all of the tutorial materials are in Jupyter notebooks, and so you can go to that URL at the bottom. It'll take you to NBViewer site that Jupyter hosts, where there's a bunch of hosted notebooks, and there you'll find the Bokeh tutorial notebooks. And so let me just show you what that looks like. So if we click on this link here, or if you go to it, go to the page. Right, so this is actually at nbviewer.jupyter.org, but this is what you should see is this notebook. And so from here, we're going to be going over several of these notebooks. I bring this URL down at the bottom, but not all of them because we won't have time. So there's that URL at the bottom. There's what you should see. I'll give everyone just a couple of minutes to get navigated there. If anyone has any problems, please raise your hands. Let me know. Definitely, if anyone has any questions at any time during the tutorial, please raise your hand or holler at me, grab my attention, and I'll come take a look. And also, as you work the exercises, if you have any questions, I'm happy to come wander out and help people with questions that you might have. So, like I said, it's a very hands-on tutorial. I think this section's a little bit, this last slot of the day is a little bit longer, so we'll probably take a little break in the middle as well. So I think, at least on the schedule, it has us going to 5:15, so we'll probably take maybe a 10-minute break about an hour in. Okay, so like I said, we'll give everyone just a minute to get there. As everyone's finding this page, you'll note there is a download button up here at the top, so you can click this download button to actually download the notebook locally. So all of the notebooks have been statically rendered in this NBViewer site, but if you actually want to run the code, you'll want to download it locally, and you'll want to run IPython notebook on that notebook file, and then you can actually execute the Python code and do the exercises. Here on this NBViewer site, it's just a static rendering of the notebooks. Yeah. That, I believe, is a Q. Yeah, let's see if I can make that a little bit bigger. Yeah, let's see if we can make that a bit bigger. Maybe not. Well, it doesn't. Oh, funny. Not giving me text options. Okay, well, there's format. Okay, I'll make that bigger. just keep making that as big as possible. All right, is anyone having any trouble finding or getting to this NB viewer site to find the notebooks? Everyone got it? Okay. So then in that case, I'm going to go to a locally running version of the notebook that I've got up and running and just talk about sort of, this intro slide, this section 00 intro, as well as talk about what we're going to be covering and sort of what we're not going to be covering in this tutorial today. So again, just for time reasons, we're not going to be able to go over, not even really half of the sections there, but just so you know what's there, Bokeh itself is split up into a number of high-level different APIs. There's a high-level charts API. We're not going to cover that today. There's the basic plotting interface, which we are going to cover today. There's lots of ways to style, lots of knobs and dials that you can turn to style and configure pretty much any aspect of a Bokeh plot. I don't think we'll get to that today, unless we have time. Sharing and embedding is another useful section, but we're not going to get to that. We're going to skip all the way down to Bokeh applications. I think that's one of the newer capabilities that people are really curious about. So again, we're going to be doing the basic plotting interface, the layouts, widgets, and interactions, and then the Bokeh application sections. But just so you know, again, there's also sections now on some geographic type things, and there's actually a lot of current interest in developing that capability even more in the near future. Data Shader, which is a related library under the Bokeh organization for dealing with very large data sets, hundreds of millions or billions of points, and I might do a quick demo of some of that. And then HoloViews is another sort of open source project that one of our other contributors at Continuum and his team have worked on. It's really great in the notebook for basically automatically slicing and dicing data and creating nice little GUIs based on the shape and the way your data is actually laid out. So anyway, that's sort of an idea of what all you can get there. We'll cover what we can cover today. Okay, so as I mentioned, what is Bokeh? Let me make this font bigger. Library for interactive visualization. It's targeting modern browsers. It really wants to be able to provide very versatile graphics that you can create. We want to be able to create standalone HTML documents that you could just send to somebody and not have any kind of server, but also to be able to have very rich and sophisticated server-backed documents as well. We want to be able to handle streaming data, large data sets, and we, of course, at Continuum we're a big Python shop, so we've invested heavily in Python bindings, but actually there are other bindings for Bokeh as well. There's a Bokeh.Scala, Bokeh.R, and so if you're interested in using Bokeh from those languages, those are available. Those are actually created by outside contributors. So there's a lot of interest and a lot of new outside contributors coming in to help with the project, and it's really exciting. So what can we do with Bokeh? Well, first thing we can do, here we are in the Jupyter Notebook. So who all is familiar with the Jupyter Notebook? Just about everybody. Who all is familiar with Bokeh? Okay, about half. Okay, so that's good. So we're gonna have a brief sort of intro starting kind of from the beginning, and then we're gonna dive into some more sophisticated stuff, but hopefully it'll be a nice collection of things for everybody. So here in the notebook, we have some sort of standard inputs, right? So here I want to import output notebook, because we're working in the Jupyter Notebook. I want to import this show function, and then I want to call output notebook, and we can see that Bokeh is ready to go in the notebook because we have this nice message that said it's successfully loaded, with a little logo there. And then we can do things like create a histogram, right? So here I'm using my high-level Bokeh.charts interface to create a very simple histogram. And so you notice that it's actually wanted to group this data by species. So we can say color equals species. There's a column species in our data. And that automatically will generate that. And so this API, I think, is very nice for sort of very quick, one-liners, sort of exploratory data analysis type things. But you can also create much more rich type applications. So here's a reproduction of Hans Rising's Gapminder demo. And so you can see this has this nice slider at the bottom, and we can scrub the slider and sort of see the data update. This doesn't require any kind of server. This is just HTML and JavaScript, right? And if you actually go into the Bokeh notebooks, you can see this get Gapminder plot. There's also a server version of this that I'll show in a little bit as well. But this is definitely the kind of thing you can do fairly straightforward with Bokeh as well. The last thing, of course, is we can do these server applications. So here I'm just going to go ahead and iframe one in from the demo.bokehplots.com site that you can also go check out. This is a very simple app that has a bunch of sliders, and I can scrub the offset here, the amplitude, or change the phase, or the frequency. I can say my, PyData San Francisco sine wave and have that update. So this is actually going back, to the Bokeh server that's running on demo.bokehplots.com that's serving this application to us, and then causing the update. So if you have some code that wants to do respond to user selections or to widgets, the Bokeh server is a great way to create applications that do that. And so we'll see a lot of examples of that today. Okay. So quick note without going into too much detail about how all this works. So the main thing is that instead of actually creating like JavaScript code to send to the browser. Bokeh is actually composed of two libraries. There's sort of a Python half of it, and then there's a separate library called Bokeh.js. And the interface between them is this declarative JSON spec. And so any language that can generate the right JSON can drive bokeh plots in the browser. Again, we're a big Python shop at Continuum, so we've really heavily invested in sort of very sophisticated Python bindings for bokeh. But you can generate, any language you want could generate bokeh plots if it generates the right JSON. And so again, that's why we have rbokeh and bokeh.scala. And actually there was a bokeh.lua and briefly, and also a bokeh.julia. So if there's anyone here interested in Julia, I'd love to try to help find a new maintainer for bokeh.julia because it hasn't been updated in a while. But okay, so getting set up. So what do we need to get set up? So again, the things you're going to want for this tutorial are Jupyter Notebook, Bokeh. The newest version is actually 0.12.1. Probably what you'll get today if you condo or pip install it. And you also want to get, actually that's it. Just Bokeh and the Jupyter Notebook should be pretty good. Pandas isn't really required. The high-level Bokeh.charts API does require Pandas, but the core library doesn't. And that should be pretty good. So let me give everyone just a few minutes to get set up. If you have any problems installing things or getting things ready to go, let me know. But once you have everything there, you should be able to do something like this. Import the version, print the IPython version, the Pandas version, and you should see something like that. So give everyone just a couple of minutes to get set up. Again, raise your hand, holler at me if you have any problems. I guess in the meantime, while people are getting set up, if there are any questions right now, before we really dive into things, take those as well. Everyone got their post-lunch food coma going on? Sure. Okay, well, as long as people are still getting setting up, I'm going to go ahead and run through again just a couple of quick demos. Because I want to give maybe a preview of some things in the tutorial, but also in future coming up versions of Bokeh. So one thing that's sort of been missing for a long time, because we really wanted to wait for some improved layout capabilities, is actually a very simple thing. But if you follow Bokeh for a while, you'll be happy to see that there's at least a path forward for adding LaTeX annotations, right? So this is actually using a custom extension. This is not sort of built into the library. There's an example that shows how you can write an extension to do this. We'll figure out how to add it to the library, proper, the core library. But for the time being, there's a really nice example that you can use. You can take this sort of custom LaTeX label extension and use it in your own code if you need to add things like LaTeX labels to your own plots. I should mention I'm really excited about the sort of extensibility capability that we've added to Bokeh recently. There's a small team working on sort of a large project with a really quickly growing user base. It's kind of hard to keep up with both feature requests, all kinds of things that people want. Some things may never make sense to go in the core library, but it'd still be great if there's a path for people to use them. And so this extensibility is really fantastic. It lets people sort of not have to wait on us, right? Sort of self-serve and create all kinds of interesting new capabilities that Bokeh can do. If there's some amazing new JavaScript library du jour that you want to wrap and use and connect it to Python data analytics on the back end, Bokeh makes it really easy to do that. And so I'm excited about that, and I'm hoping to have a nice mechanism for people to share these contributions. If you think of like the Atom, sort of plugin loader, I want to have something similar to that for Bokeh, so people can create these contributions and these extensions and share them very easily. And I think that'll magnify the value across the entire community. So that's sort of things that are coming up as well. That's one thing. Another thing that's been missing for a while that people have asked for, probably shouldn't be so bragging about it. It took so long to get us, but we'll have some color bars very soon in the next 0.12.2 release. So again, this is really waiting on some layout capabilities that only just now sort of came crystallized. We didn't want to sort of write something hacky and then have to redo some work. We just don't have the ability to sort of throw work away. But anyway, so that's coming very soon in the next, actually should be a couple of weeks in the next 0.12.2 release. Since we are talking about Bokeh applications today, I actually want to show you what some of these are. So if you go to demo.bokehplots.com, you can check these out yourself. But here we can click on this one here, and we can see this nice sliders app. And so I can go and I can change it. And the thing about this is that it's a very tiny amount of code, right? If you actually look at the code for that entire app, have a scalable, deployable web application. There's no web code in here. There's just some Python, some imports. We'll talk about what all this is later. Some code to add the widgets, a callback, and you're sort of pretty much done, right? So a very tiny amount of code to have these kind of applications. Another one shows off a nice capability is, what if you want to respond to things like user selections, right? So this actually shows some histograms of the data, and then if you make a selection, you get a histogram both of the selected points and in the mirror image, the unselected points as well. And so this is the kind of thing you can do with, Bokeh server plots, is respond to things like selections. Another one here, again, this is sort of a server version of that Gapminder example. We can hit a little play button here and sort of it'll animate through and go and update everything. This also shows off the capability for using Jinja templates, right? So Bokeh applications now can have their own templates. So if you're in the realm of sort of a single page application that you want to have heavily centered around sort of Bokeh plots or visualizations or things like that, it's really easy to make just a straight Bokeh server application, not have to embed it in something else. Okay, last few here. Again, another example of a custom extension model. There's nothing built into Bokeh for 3D stuff, but I found this nice little library called Viz.js, and I wrote 10 lines of extension code to sort of adapt the Viz.js data structure to a Bokeh column data source, and then use the streaming API to push data to it, and so we can have this nice sort of 3D thing. So again, the whole idea behind the extension API is that people don't have to wait on us. If there's something really cool or amazing you want to do, we don't have to be the gating factor. People can do really awesome things on their own. So I'm very excited about that. What are some other good ones here? Last one, again, using templates, is this nice little sort of cross-filter application that one of our developers, Brendan Collins, put a lot of work into. This, if you maybe want to color it by the horsepower column, or change the size according to the miles per gallon, you're able to sort of do that. This is using the AutoMPG, or I think it's also called MT-Cars data set. Okay, last but not least, we also wanted to do a sort of a comparative one. This is actually a reproduction of the R Shiny Movies app with a couple of small changes. But here you can see we can, again, scrub sliders and sort of these things update sort of as fast as we'd want. So anyway, this is sort of what we're getting to. So we'll talk a lot about the details of what goes into a Bokeh app a little bit later on in the tutorial today, but I wanted to give you an idea of what's there. For another example of a really cool one, if you actually go watch the recent SciPy talk that Matt Rocklin and Jim Chris gave about Dask, which is this distributed array scheduler, they wrote a really fantastic Bokeh app that, so Dask is this array scheduler that lets you schedule jobs across, whatever, 32, 64 cores, and they wanted to be able to monitor the performance of this and see what's going on in real time. And so they wrote this Bokeh app you can sort of see over here on the right that will start showing exactly what's going on as the computations proceed. You can sort of see all kinds of here these cores are doing compute jobs, or I think yellow means IO, or something else means blocking, and so they can see in real time what all the different cores in this cluster are doing, what the Dask jobs or what state they're in. And so this, I think, is a really fantastic job, and so they use a lot of nice techniques to sort of build this cluster management tool using a Bokeh application. So again, you can see that if you go to the SciPy talks on YouTube, you can see the Dask talk there. Okay. Last but not least, I always have to show this one. I've been trying to show it in its full glory for a few years. Originally wrote this spectrogram app several years ago, and originally it was actually a lot of JavaScript using Bokeh.js directly, maybe 600 lines or something like that, which was sort of cool to look at, but nothing you'd ever want to write. And then we got a little bit better using more Python and less JavaScript. But now we have a Bokeh server version that's really hardly any JavaScript at all. So this is really just using Bokeh code. You can do things like scrub the slider and see the things change. And so this is actually doing a Fourier transform. It's reading the microphone off there and doing the spectral analysis, and you can see the power spectrum and the signal, and it's, it just shows up. And so this is, again, the kind of thing we want to enable. Been trying to write this app for a couple of years, and we're finally in a position now where we can actually write this almost completely as a Bokeh server app with one small custom extension model to help with the streaming of the image data. Okay, we've got that. And then last but not least, I just want to mention, again, we're not going to talk about it too much today, as I just wanted to mention this associated data shader project. It's really for dealing with much larger data sets. So there's just a simple demo here in the tutorial, but you can take a look at it, on your own. But what data shader is meant to do is to do offline or not in the browser rasterization, right? So if you have 10 million or 100 million or a billion points, and you just try to do a scatter plot of all of those points, well, one of your problems, of course, is that you don't want to send 100 million points in the browser. That's not going to be a fun day. But even if you could, it's not the right thing to do from sort of a visualization perspective, right? Because you're going to get a lot of overplotting, and it's just not going to be useful. And so what can we do about that? Well, Jim Bednar and his team have worked on this data shader project Used to be called abstract rendering, sort of initial conception of it. But the idea is to be able to do a perceptually accurate rasterization very efficiently, and then send a low bandwidth image to the browser. And so this is an example of that. You can see it doing some of the work with the census data, the New York taxi data shaded by reported race. Jim has some nice benchmarks using the 2.8 billion points at OSM street map data as well. But just for a quick example here, it also integrates really nice with Bokeh. And so that's the sort of the point that I want to drive home. Right here, I've created a 100 million points, sorry, actually 10 million point data set. It just has 4 sort of distributed Gaussians. But we have this interactive image at the end that, you know, one, it can draw this fairly quickly. But if we go ahead and zoom in, what's nice is that we get progressive refinement, right? So this is 10 million points, and this is just on my laptop, right? So we can sort of zoom in and really see the fine levels of detail. We start to get to the levels of individual points. This is a really interesting demonstration with the census data, which I just don't happen to have loaded on my laptop. There's this census data explorer that lets you zoom into individual neighborhoods, and you start seeing, you know, not just the aggregate behavior when you're zoomed out, but actually the individual, you know, data reporting points at whatever level you want. So anyway, so that's, I think, a nice thing. Again, there's a tutorial on this. Jim's notebooks are very expository and have a lot of explanatory text that talk about exactly what's going on, so I definitely recommend checking those out if you have time. Okay, so that is just, again, some overview, some demos, something to whet your appetite. We're going to talk a little bit about some basics at first, and then we're going to dive into sort of layouts and interactions and Bokeh applications for most of the tutorial. But before diving into that, I guess I want to pause and see, is everyone set up? Has everyone got things installed? Any issues? Any questions I can answer? Okay. All right, well, good. I guess it's a good sign that things are getting easier and easier to install. Great. Okay, so the notebook that we're going to look at is this number 2, basic plotting interface. So you should download that one locally. So you can go to it on nbviewer.org if you just want to sort of follow along and look at it. If you actually want to run code, you want to download that notebook and then run Jupyter Notebook on it, or IPython Notebook on that file. Does anyone have any questions about how to get that notebook file running locally? Okay. In that case, let's take a look at it. Okay. So, as I mentioned before, Bokeh has sort of a layered approach to APIs. There's a Bokeh.models interface that's a very low level. It's sort of building blocks. You can imagine a bunch of Legos that you can put together in whatever order you want. It's the most expressive and the most, you know, sophisticated, but it's also maybe the most, you know, verbose, right? And it's also possible to put things together in ways that don't always make sense, right? So, you know, it really is what mirrors the Python side to the JavaScript side. There's a corresponding set of objects. You know, some models are things like axes or data sources or, you know, labels or, you know, ranges, all of those things. And so everything on the Python side is mirrored into the browser as an object in the browser as well. And that's how we synchronize everything up. And so it's possible to use that and create really fantastic visualizations. Again, it's a little bit more work. It's sort of the most verbose layer. At the other end of the spectrum, there's a very high-level Bokeh.charts interface. This is the newest API, probably the most under development and sort of the most, seen the most churn. It's really, the idea is to be able to do sort of basic statistical computing in very short order, histograms, violin charts, box plots, you know, all of these sort of things in sort of one-liners, and get images out very quickly with less work, and sort of do lots of reasonable defaults, right? And then in the middle, and what we're going to talk about here is the Bokeh.plotting interface. And that's sort of my sweet spot. That's pretty much where I primarily go to. Some people start with Bokeh.models. Some people, you know, really love to use Bokeh.charts or anything. Bokeh.plotting is sort of my happy place, and so that's what we're going to talk about today. But it's sort of the mid-level, around the same level of specificity as sort of a Matplotlib or MATLAB or something like that. And the whole idea is that you want to be able to attach to basically any visual primitive either sort of a fixed value for it or a column of data that comes from one of our column data sources. And then around that, Bokeh will construct sort of a generic, reasonable default plot with default axes and you know, default ranges and things like that. And so you can just sort of throw data at these visual shapes and get lots of interesting things out. So let's take a look at it. Okay, so the main things you're going to be using imports that you're going to need to use Bokeh.plotting. Again, from Bokeh.io, we want to get output notebook in this case, and the show function. There's also an output file function if you just want to generate an HTML file. And then if you want to embed things in like a Flask app or a Django app or whatever, there's a Bokeh.embed.components function that you can use to get the right divs and script tags to do that. But for this case, for the notebook, we're going to get output notebook. And we're going to also import the figure function from Bokeh.Plotting, right? So we can execute those sort of standard inputs, and that works great. Then we can execute output notebook. We can see that sure enough, Bokeh.js has loaded. I'll mention by default, Bokeh.js loads from CDN. It's also possible to make inline, to use inline resources, which would make a notebook that's truly self-contained. It would have all the JavaScript. Of course, it's going to be quite a bit bigger because it has Bokeh.js library embedded in it. But it would be completely self-contained. You could use it, for instance, behind an air-gapped network or anything like that. So, okay. So let's use Bokeh.Plotting to create some basic scatter plots. So again, we're going to have this one sort of section of the tutorial that's fairly basic, and then we're going to move on to some more sophisticated things. So we want to create a new figure. We want to create a new plot, rather. So we use this figure function to do that. I'm going to give it some options, things like plot width, plot height. We can give it other options. There's options for axis labels and the size of the border that you want, that sort of thing. We get this plot object back. And then we want to call p.circle on it. So p.circle is a function that says I want to create a bunch of circles. And so in the simplest case, we can just pass Python lists of data. In this case, I'm just passing some lists. We could pass NumPy arrays. We could pass pandas, data frame columns. Pretty much any sequence will work. And we'll go ahead and get some circles out that. We want to give it some other parameters like size equals 15. So size is a data space screen space unit. This is how big we want the circles to be. We can specify things like the line color, the fill color, and the alpha for these circles. And then we call show, and that's what's actually going to show it as our output. And so we can see that sure enough, we get a bunch of circles. Since I've specified a size, which is in screen space units, then if I do things like zooming in and out, we'll see that they don't get bigger, right? Because size in screen units is absolute, right? It's pixels, basically. So they don't actually get bigger as I zoom in and out. You also notice, though, that again, Bokeh.Plotting basically generates sort of a default set of tools, a default set of, sort of a nice axis that auto ranges. You can see there's sort of a save button that lets us get a PNG out. I should add programmatic headless saving of PNGs and SVGs is also something we're finally inching towards as well, hopefully using Chrome headless, which is also a new project, but we are working on that. But it's got things like a pan tool we can move around, or a box zoom tool. All of those are just sort of standard and work. A reset tool here to go back. So anyway, this sort of standard set of tools, standard axes, and the idea is you can throw these glyphs up. We call them glyphs. So things like markers, scatter markers, or all the shapes and lines that we can draw. We call those glyphs. And so in this case, you want to be able to throw glyphs at a figure, and that's what Bokeh.Plotting is all about. You might notice it also returned this thing called a Bokeh notebook handle, since we're in the notebook. That's actually to be able to update plots sort of in place. And we'll see some examples of that a little bit later in the interactions category. So there's a nice push notebook function that if you're working in the notebook, you can really easily sort of have IPython widgets update your plot interactively as well. So we'll take a look at that a little bit later. But let's go ahead and do a quick exercise. And we'll take a few minutes for everyone to sort of look at things. Basically, we want to just copy and paste this first example. And instead of using size, let's see what happens if we use a radius for our circle. And certainly if you want to change some other properties as well, whatever. If you have some favorite colors, fire brick is a go-to for me for some reason. Not sure why. Might be initially surprised by the reactions, but if you zoom out a bit, you might sort of see what's going on. Okay, so what happened when we used radius instead, right? So the first thing is we just replace size with radius, and we get our plot, and we're like, whoa, what's going on here? And if we zoom out, we might get some idea of what's going on. Well, radius is in data space units by default, right? So here I've set a radius of 15, so we can see, sure enough, we've got these really big circles that sort of overlap quite a bit, but they get bigger or smaller as I zoom in and out. And that's because, again, they're scaled to sort of data space units. They're scaled to the axes. So we can try some smaller radius, maybe 0.15, and we can see, sure enough, we've got much smaller circles here. And if we were to measure sort of how big those were, we'd see that they're 0.15 in sort of data units. And again, if we zoom in and out, we'll see they get bigger or smaller as we zoom in and out. And so that's where the distance or difference between size and radius. Any questions about that? Hopefully fairly straightforward, probably familiar to folks that have already used Bokeh. There are a lot of other markers. Circles, obviously one, but there's things like p.square, right? Fairly straightforward. You can just call p.square, and then sure enough, now we get squares. Notice here that instead of giving a fixed size, I've actually given an array. And this is actually important. So again, the whole notion about all of these glyphs is that basically any visual property that they have, the XY position, the size or radius, the fill colors, the fill alphas, all of these properties can either be a fixed value, or they can refer to like a list or a sequence of data. And using the figure interface, we can pass in an explicit list like I've done here, or a NumPy array or whatever. A little bit later on, we'll see how we can construct column data sources ourselves, and then we can actually refer to the names of those columns is another option or another way of doing that, but we'll see that a bit later. But so I can put in this here. If I were to change this to 10 here, then sure enough, now they're all the same size. So put that back. A lot of other markers. You can click on any of these, sort of see examples in the documentation. Asterisk circles, circles with X's and crosses, triangles and inverted triangles, all of them standard things you would expect from a plotting library. So you can sort of click on those and see any of them. Any of those are available. So quick exercise. Maybe we'll just take again a few minutes for folks to sort of take the code above and modify it a little bit and see what they can see. So go ahead and maybe just take like 2 minutes. One other thing to notice here actually is notice that I put color instead of line color or fill color. That's just an alias that the figure, convenience that figure accepts. So if you do color, that will set both the line color and the fill color, right? So it's just a little shorthand.
Sorry, Ryan, do you guys
yes.
have C-map equivalent? Or let's say I want to give an array of colors and categories and data?
Yeah, absolutely. So in Bokeh.charts, we'll do some of that automatically for you. Bokeh.plotting, you can give a list of colors. Another feature that's coming up pretty soon, we've added some infrastructure and plumbing for doing basically transformations. So I mentioned you can have a fixed value or a column of data. It's actually, now you can have a transformation on a column of data as well. And so we have some examples that do, for instance, jitter. But we haven't quite hooked up a color mapper yet. It'd be a pretty simple exercise, so we should do it very soon. But that would let you do color mapping on the client. So you would say, I want to color map this column of data using this palette, and then that would actually happen in the browser. So you wouldn't actually have to send all the colors like you do now. So that's coming very soon. But that's a good question. The question was, is it possible to sort of send lists of colors? You can do that explicitly. If I go here, I can say color equals fire brick and the blue and the yellow. And you can also do hex codes, of course, for colors. Olive is my favorite green color here, and what's a good last color? I guess gray. So here I've given a list of colors for the color argument, and sure enough, they all show up different colors, right? So that's possible to do now. With Bokeh.plotting, you just give the list of colors that you want. Bokeh.charts will sometimes do that for you. If you say I want to group by some, the color by some column, it'll actually do a group by and color each group differently. And then very soon in Bokeh.plotting, you'll also just be able to say, I want to color map this column according to this value in this palette. So that's going to be a good question. Let's see, some other parameters here we can change. We can change the line width equals 4 or something. That's also in screen units. Fairly straightforward stuff, but we can see that makes sort of thicker lines. So again, all of those properties, basically any of those properties there can be fixed values. They can be columns of data, sequences of data, references to columns. And again, they can also be transforms on columns, which we're not going to talk a lot about today, but they're pretty cool. I refer you to the jitter example in GitHub if you're curious about that. Okay, any questions so far? Okay. Line plots, probably want line plots as well. Scatters are great. So there's p.line, same idea. You can give it fixed value, you can give it a sequence of data, you can specify things like line width. Sure enough, I call this and I get a line out. Nothing too spectacular about that, but it's hopefully fairly straightforward. Again, nice default plot, lets us have that connected line. Images, another glyph we have is the image glyph, right? So in this case, image, we're going to use the image RGBA glyph, which it actually just accepts an array of RGBA data. So if you just have literally RGBA data, you can plot that here, right? And so this uses kind of some fancy NumPy indexing. I'm not going to go into details of that, but it uses some fancy NumPy indexing to set the red, green, blue, and alpha channels, basically of this array, to create this image of RGBA values. And then we pass that to image RGBA. Sure enough, we get this image. And again, we can sort of have standard tools, and we can zoom in and out, and all of that works fairly simply and straightforwardly. A lot of other kind of glyphs. Not going to go into too much detail here. Hopefully that gives you the flavor of how to proceed, and you can look in the documentation, which has lots of examples, both in the reference guide and also the user's guide. But of course, there's things like rectangles and ovals. We actually just added some really useful new ones. We added V-bar and H-bar, right? So rectangles are sort of, you give a center point and an angle and a width and a height. And of course, quads, you give top, left, right, bottom. If you want to draw bars, like if you actually wanted to draw a stacked bar chart using Bokeh.Plotting, you kind of want the hybrid of those, right? You want to specify maybe a center and a width, and then a top and a bottom. And so that's what V-bar and H-bar give you. And that was just added by an outside contributor. I'm really, really excited about sort of the increasing pace of outside, sort of new contributions and new contributors we're getting. I think we've got 180 contributors on GitHub now. A lot of those are sort of very small, PRs, but we're starting to get bigger and bigger PRs as well. And so I'm very excited. If you're looking for, an open source project to sort of get involved in, we're always trying to be extremely helpful and extremely welcoming and answer questions as best we can. So please don't be shy if you're interested in contributing. So that's those ones, segments and rays, wedges and arcs if you want to draw, of course, like some kind of donut chart or pie chart. We've got these, wedge and annular wedge and annulus kind of glyphs. And there's a few specialized curves that I haven't used myself much, but I'm always interested to see what users come up with. There's like a Bezier curve glyph and a quadratic glyph. And someone added a nice chord chart using those recently. And again, a new contributor added those. So actually, let's go ahead and take a few minutes. If folks want to click on some of these, you can go to some code examples, but you can run them here in the notebook. And I'll pick one, but you can pick whatever you want. We'll take just a couple of minutes and maybe take a look at some examples. So actually, here to GitHub. Okay. See if I can't find a V-bar glyph. Oh, interesting. Yes, absolutely. So you can set which tools you want at all in the toolbar, and then you can also set now, and this was a recent request that we added, which tools initially start out as active. So yes, all of those are configurable from Python. Yes. Yeah. Yeah, good question. So let's see. So actually, this is a good point to go. If you go to bokeh.pydata.org is the documentation site. We have a reference guide that's sort of generated automatically, and you can go and you can see all of sort of the low-level information. I mentioned we have these things called models. If you go to for the glyphs here, let's go to bokeh.models.glyphs, and then we can look at the circle one. You can see some nice examples here in all the reference docs, but you can see all of the different properties that all of these have. So things like fill color, line alpha, line cap, all of the things that the glyph has. In particular, we can look at, actually I think it's bokeh.markers would have circle. Yeah, so there's the circle glyph. So we can see that it has either radius, or size, right? Because it's a marker, so it has size, but it also has this extra radius one because it's a circle. And you can also specify whether the radius units are screen or data space, things like that. So all of that's there. Let's see if we can find the, test my knowledge, see if we can find where the documentation for the tools went. So I think that would be in the user's guide and under configuring plot tools. And if we go to level detail, Drag tools, setting active tools, right. So there's a whole section on setting active tools here. And the way this works basically is plot itself has a toolbar attribute, and so you can say things like, I want the active drag tool to be none, I want the active scroll tool to be auto, which is just whatever Bokeh would pick, or you can set it to a specific tool. And so there's some examples of that. So anyway, that's right there in the user's guide. We've tried to make a really big push on our documentation in the last, 18 months really, but it's a big job keeping up with things. But I think our user's guide is fairly comprehensive. We have a lot of inline examples, code with live plots that were generated by that code. So we created some nice Sphinx extensions for really helping us create, I think, better documentation. So certainly though, if you have any suggestions on how to organize it or make it more searchable, or if there's something that's missing that you think should be added, we always welcome that kind of feedback. I will mention actually now, because this comes up, Google itself seems to return a lot of old results. I'm not sure how to fix that. But the actual site search is quite good. So if you go to things like column data source here in the site search, you'll get back this nice thing that says I want V12 results, V11 results, or the latest results. And you can see that it's only giving me back relevant results. So this is, I would say, if you're looking to search the docs using keywords, start with the actual site search. You'll probably have a better result. The complaint that we get sometimes is that if you just go to Google and search for column data source, you'll get results for Bokeh 0.9 or 0.8 or whatever. This way you'll always be able to get the version that you want. Okay. So anyway, that was a good diversion. So thanks for that question. All right, so if we go back to this, I just want to run this right quick. Also just to give you an idea, since we're not going to talk about Bokeh.models, but I at least want to give you maybe a little bit of an idea of what things look like. This is sort of how things are again, a little bit more complicated, right? I have to create all so this just to be clear, this is an example of using Bokeh.models, but I wanted to show those V-bar glyphs. This is where you would have to create the axis and add it yourself and create, a grid and add that yourself and sort of create a document and all of those things. But if we run it, oh, we don't need this in the notebook. This code actually wasn't meant to be run in the notebook, so I may be out of my tab here. We don't need documents. Plot, yeah. Okay, well, that may not actually work. So this code was written to not run in the notebook, and it had some sort of fancy document stuff in, and I may have to restart my kernel to make that work. But anyway, just to give you an idea of what that level of specificity looks like for the Bokeh.models layer. Okay, last sort of section here, just want to make it clear that because we haven't done it explicitly, it's possible to combine as many glyphs as you want on one plot, right? Either with the same data or different data. So let's take a look, maybe we want to have a line that actually has sort of circles around it. And I seem to have gotten, so creating that other document, restart my kernel. Sorry, creating that document explicitly from that code that I copied was not a happy thing. The Jupyter Notebook's an interesting and challenging environment to run in just because of the sort of way you can affect sort of global state across cells. But anyway, we'll restart that. And then, here we go. Yeah. So yeah, so if we want to see multiple glyphs together, that's really easy, right? So here I just plotted a line with some XY data. In this case, I've got X and Y defined up here as some variables. These can be lists, NumPy arrays, pandas, columns from data frames. And then again, I plot a circle. And so the glyphs here are going to be plotted in whatever order I provide them. So the line's plotted first, the circle's on top, you can see it. Sort of plots that way. Again, I've used the same data for both of these, but of course you could use whatever you want. You could plot multiple circles with different sets of data or whatever, anything like that. So last little exercise here, why don't we go ahead, everyone sort of play around with this yourself and make sure things are working, and then that will be good. Change this up. Just as an example, we'll go ahead and import NumPy CNP. So I have NumPy installed. We can let np So again, perfectly fine for those to be NumPy arrays. We could load some data from pandas and pass in pandas as well. Pretty much any sequence. Okay. So that's pretty much the end of this first section of the tutorial that I wanted to go over. Normally after this, we'd go into a section about sort of styling visual attributes. So again, there's lots of knobs and dials if you want to change the appearance of all the ticks, you know, the fonts and the colors, the way things are laid out. If you want to change the grid or the axes colors, you know, the title fonts, pretty much anything you would care to configure, you can. So there's a whole tutorial section about that. There's a lot of information in the user's guide as well. We're going to skip over that today just for the sake of expediency, but I just want to let y'all know that that's there. And that's good. Maybe we can actually just take a quick look at that. So yeah, so if we go to styling visual attributes, just to give you an idea of what's here, in case you want to go to it later, you can sort of see there's lots of things you can configure, you know. Things like the glyphs themselves can be configured. Actually, this is something that's interesting. If you have selections, it's possible to control the appearance of selected and unselected things. So here, if I click on one, I can specify exactly what the selected and unselected glyphs should look like. Also hovers, right? So if you want to specify like a hover policy, so here I've set a hover tool with a horizontal line for hit testing, and so you can see that the hovered glyphs that are hit by that horizontal line get a specific policy, and this tells you how to set those kind of visuals as well. Again, axes, you know, if you want to control the orientation or the size or the font or whatever of the ticks, you can control that here. You know, if you want to have differently colored fonts, if you have multiple axes, maybe you have multiple y-axes, and you want to have different colored fonts for the axes to specify different, you know, sort of correspond to different lines of different colors. That's a pretty common use case for that, I think, as well. Yes? Yeah, absolutely. So, yeah, so here's the code here. Let's take a quick look. So yeah, so I think we're doing pretty good on time, so I think it's worth taking a brief diversion here before moving on. The way that is specified is you call p.circle just like we did in the previous example, but here I can give not just fill color or, you know, fill alpha, I can give hover fill color, right, or hover line color, right? And so in this case, my hover fill color is firebrick, and my hover line color is white, and you can see that's exactly what I've got here. And so I've added a hover tool. And the mode there, H-line, means that it should basically correspond to a horizontal line wherever the cursor is. And so anything that's hit by that horizontal line, that'll be considered hovered over. And so you can see that it just updates that. So I haven't had to do any kind of extra work to do that or write any JavaScript to do that. All of that just sort of falls out. Yeah. So here I've specifically added a hover tool. So, you know, there's a set of default tools that plots have when you use the Bokeh.Plotting.figure. But you can also add specifically customized tool. In this case, I've added a hover tool that I don't want any tooltips, and I only want it to look at my circle renderer, and I want it to have this sort of horizontal H-line hit testing. And so, you know, you can certainly explicitly add tools using these low-level tool models. Same thing, and this is basically the same interface for the selections. Here I've given a non-selection, you know, fill alpha of 0.2 and a non-selection fill color of gray, and then a selection color of firebrick. And sure enough, if I select something, the selected one is, you know, sort of filled firebrick, and then the other ones are sort of have an alpha and filled gray, and, you know, that works even with multiple selection here. So I've, you know, I can use the shift key to do multiple selections. So. Anyway, so again, this is a nice reference. The user's guide also has a lot of examples like this for any of the sort of knobs and dials that you might want to sort of you know, change properties. So, any questions about that though before we move into the next chapter? Okay, great. Well, then in that case, let's go back here to the plotting, and we're going to go on to chapter 4, which is interaction. So I'll give everyone just a moment to download that from NBViewer. So if you're on NBViewer, again, you're going to want to go to chapter 4. There's that nice download button in the upper right-hand corner, and then you can run Jupyter Notebook or IPython Notebook on that file, and then you can actually execute code locally. Or if you just want to, if you're just on NBViewer, you can sort of follow along and look at what's there in those rendered static notebooks. But if you want to execute code, definitely download it locally. So give everyone just a minute to do that, and then we'll probably do one exercise and then take a break. font big enough, by the way? Make this bigger. Is that better? It's probably better. Okay. I can just make this bigger as well. Okay. So this next section is about sort of layouts and widgets and interactions. They all kind of go together. In order to have widgets, you need to have a layout to be able to lay things out together. And then typically if you want interactions, they're in response to things like widgets or tools. And so it all kind of goes together. And so we're going to start with layouts, and then we're going to move on to how you can get some really nice and interesting and sophisticated interactions in Bokeh documents. So again, our standard imports here, output notebook and show from Bokeh.io. We call output notebook. We can see it's loaded. That's great. So the first layout I want to look at is called grid plot. So there's a module called Bokeh.Layouts. You can import grid plot from it right up here. Again, this example is going to be using Bokeh.Plotting to create a figure. And actually, we're going to create several figures, right? So here I'm creating some x values, some y values. Basically, I'm creating sort of a straight line in different directions, and then I'm creating a sort of absolute value, just using list comprehensions in Python. Again, it could be NumPy arrays or pandas columns, whatever you want. And then I'm going to create 3 plots, right? So I'm creating S1, S2, and S3. So I call figure 3 times. I give it, in this case, I want sort of smaller plots. So I give it sort of plot width and plot height smaller. I create the first one with circles, with x and y0. The second one with triangles, x and y1 is the coordinates. And the last one with squares, with x and y2 is the coordinates. And again, I can set all those properties however I want. I could have an array of colors, an array of alphas, or whatever I would, any of these could be vectorized. In this case, I've given single values. And then I want to put them in a row. So I call this grid plot function, and I can basically give a nested list of lists of layouts. So if you're familiar with sort of other layout functions, I think it's fairly similar. I've got, the outer one says that I've got sort of one column here, and then in my column I've got one row, that's this inner list. And in that row I want S1, S2, and S3. That's sort of how that nesting structure works out. And so I create that from grid plot, that gives me this grid plot thing, and then I can call show on it. And sure enough, I get 3 plots, right? And all of these are independent. I can move this around. Note that on grid plot, I've also specified toolbar location equals none. If I wanted a toolbar, by default, grid plot tries to coalesce the toolbar. So if I wanted a toolbar, I could add it, and I would get one toolbar. And basically, this controls the active tool for all the plots. So I could change this to wheel zoom, and now they all have a wheel zoom active. I can hit reset. I can change it to box zoom, and now they have box zoom active. And so it really just depends on how you want. But that grid plot, that toolbar location will let you not have a toolbar if you don't want it. Okay, so first exercise, and then let's take a break, which is just to sort of create your own grid plot. Create a couple of plots and put it in a grid plot. Maybe let's create 2 grid plots, or 2 plots, and put them in a grid plot. Again, you can sort of probably start by copying and pasting if you want, but you might have some more interesting data that you'd like to put in. Maybe you have some local data that you want to plot. See what I can create here with NumPy. I'll make those so big. Can also, of course, put those in a column if we wanted to. We'll see in a minute there's an easier way to make columns, but you can certainly do columns using grid plot as well. So here I've created, here's my outer parentheses specify column, a column, and within that column there's one row, another row, and another row. Okay, so what have I done here? So again, I just switched to using some NumPy. Again, you might have some more interesting data locally that you want to look at. Here I just created y equals x, y equals sine of x, and y equals absolute value of x. And again, I can put those in a grid plot, and I can use that to make a column. I could do something like this as well if I wanted something a little bit more different looking. Right, so here, it's very flexible. If you want to have one on the top row and two on the bottom, that's certainly fine. So there's one plot in this first row and then 2 plots in the second row. So that's sort of the flexible way to combine and put things together. Okay, so that was actually the second exercise as well, the stacking vertically. So before we get to linked interactions, which is actually, I think, probably something getting a little bit more interesting, why don't we go ahead and, again, take a quick break, 5 minutes or so. I have 5 till 3, or 5 till 4, rather. So let's reconvene right at 4 or so. Just give everyone a break if you want to get a drink of water or coffee. And then we'll get started again in about 5 minutes. Certainly happy to answer any questions, of course, during the break if people have questions. Mm-hmm. Yes, the question's about the spectrogram. Yeah, it's in the GitHub repo. It's under examples. So yeah, so let me actually, maybe I can show people the GitHub repo while we're sort of taking a little break. If we go to Bokeh or GitHub, Bokeh. So if you go to examples, in this case it's app, and you can see there's quite a few. So that cross filter is almost everything that's on that demo.bokehplots.site is in here, plus a few extra ones, like this streaming OHLC ticker, and then also the spectrogram as well. So yeah, spectrogram is there. Sorry. Yeah, so it's Bokeh/Bokeh. So if you just github.com, and then it's Bokeh/Bokeh. Yeah. Is that, so you're familiar with GitHub? Okay, yeah, so the Bokeh/Bokeh, if you go to GitHub. Yeah. Okay.
And he produces a podcast.
Okay.
And I just interviewed the guy from one of the guys who was at D3DJ.
Okay. Yeah. No, yeah, quite possibly. Yeah, I've done a podcast on it, and so I'm happy. Yeah, I'm happy to do an interview anytime. So sure. Yeah, my card is on the table. If you want to grab one of my cards off that table, yeah, continue to. But
and could you also bring that? Could you sort of edit an example? And I didn't catch up with you.
Okay.
So this one, if you could show me the code.
Absolutely. Yeah. So. Absolutely. Yeah. No. So it's just the way the nesting is. It's in this case for the outer parentheses in the column. I've got a row that's 1 plot and a row that has 2 plots. And so we'll see some other ways to play out here in a minute. But
I was interested in what you had after the import stage. I think you changed the.
I just used NumPy. So just to show that you can use NumPy. So NumPy is this array library for Python. Yeah. And so I just wanted to show perfectly fine to use NumPy arrays as the values for x and y, things like that.
I'm really interested in very high resolution data sharing.
Okay.
Well, I've done a lot of work with Blackwell.
Okay. Yeah, you might definitely be interested in that data shader project as well.
Data shader. I was just looking at that.
And that's also, it's in the Bokeh organization, it's Bokeh/data shader.
Okay.
So yeah, it's a separate project, but it's sort of under the Bokeh umbrella organization. So yeah, great.
I'll get your card.
Great, thank you.
Cover that, because let's say I make these plots, how do I export them to, let's say, PPT or
Yeah, so that's what we're working on right now is that static. So right now you can use a save button and generate a PNG, but headless generation without a browser is.
like a slider and all one word.
No, that would just be, yeah. So as far as I know, I don't think PowerPoint lets you embed, anything lets you embed JavaScript, you're fine. But if it doesn't have embeddable JavaScript, then it's not.
We'll have to use an iPad if you're doing some kind of slider or a hover.
Or just a web page, right? I mean, you can serve it from Flask, right? You don't. The notebook's convenient for teaching, but
There's a couple different ways you can do presentation modes and use your notebook.
yeah, actually,
It has a built-in slideshow.
yeah, and actually that would work fine. So, very cool.
Quick question.
Mm-hmm.
Can't believe I have to ask you this. Charts.r.
Yeah.
How do I get layout, size and layout? I don't just end up with a square box. I've tried.
I think there's a default stuff. Let's talk about it afterwards. I don't know offhand. Yeah, I don't. Yeah, Sarah would
Tried
know.
size, shape, width, height.
Fabio, I think.
I tried doing a figure and then that didn't.
No.
I just want to call bar and I want to give a size.
Yeah, to the plot.
It generates.
If plot width,
I can't find the
there's like from charts important defaults. So this is something that Nick came up with. which isn't used elsewhere, but I think you can give a plot width and a plot height on charts.defaults. So if you do from Bokeh.charts import defaults, there's like defaults dot either width or
I
don't.
want to change my defaults.
Yeah.
So I want to just do it.
I see. You might just try, if,
Can I just try it out?
let's take a look. You can ask Fabio, might know too. Yeah. Hi.
My name is Sandra.
Hi, nice to meet you.
I want to ask you this question about, this is mostly about creating graphical web apps, right?
Yes.
So if I want to, let's say if I want to make code, and everything resides on the web,
Well, so Bokeh generates HTML and JavaScript, right? So Bokeh creates, well, actually, the Python library creates a JSON, really, is the main output. And then there's a JavaScript library called Bokeh.js that can consume that JavaScript and generate plots in the browser, right? And so, you can generate HTML files using output file. You can generate them in the browser in Jupyter Notebook. You can use the embedding library, the embedding APIs to do like Flask or Django and have web pages that have things embedded. Like all of this, for instance, all of this documentation, right? If we go to the documentation and we go to the user's guide, we can go to, styling visual attributes. All of these plots are, there's a lot of it, it's going to take a little while to load, sorry. All of these are embedded Bokeh plots, but they're live plots, right? These are actually, this is, I can pan and, pan this around, right? And this is the code that generated it, but it generated some a div and a script tag that got embedded here, and that's what creates the plot. And so that's so that's for sort of standalone documents, and we'll come to the Bokeh server in just a minute.
does it make sense that, I don't know if my next question makes sense or not, but is it possible to integrate, if I have very many code with Bokeh in iOS or Swift or Objective-C?
So quite possibly. So the thing is, there's to my knowledge, no one's written like a Swift or Objective-C binding. But the thing is, you could write it in Python, export the JSON, and then you could use that. That's certainly doable. Yeah, that's a little bit more roundabout, and we could maybe make it easier.
I know there is something rich between the Python and the Objective-C, but the question I have is, and then I translate the JSON from JSON, I can use it with the
Yeah, because there's actually an auto load static function that just takes that JSON and just loads it, right? And so you could do that. You could sort of create the JSON with Python, and having done that, then you could use it in a Swift or iOS app.
So this is a question I want to know for you. What's the difference between what you're doing in Python, for instance? What's the addition? So it seems to me like you have grown everything from Python that you added to it. So if I go to Python, why the same thing?
So like I said, the main flexibility, the main idea was to make it very decoupled and flexible, where there's this completely separate runtime in JavaScript that takes a declarative interface. But like the Python doesn't generate code, it generates this JSON declaration of what the plot should be. And so again, any language that can generate the right JSON can make those plots. So you could imagine writing Swift or iOS to generate the right JSON directly. I'd love to see that project. That's a bit of an undertaking to do it in general, But someone's done that for our Bokeh. Someone's made a Bokeh.Scala that generates the right JSON, so you can use Scala to generate Bokeh plots, or R to generate Bokeh plots. But you don't lose anything by going from Python, I don't think. The Python binding is very complete, and pretty much anything you can do with Bokeh.js, you can do from Python.
You see, this is one thing. If I don't want to rewrite everything,
Yeah.
if I want to use the Bokeh.js, okay, the JavaScript from that,
Yeah.
then in that case, will I have to go back and recreate all that on Python? Right?
if you
Because it seems to
just
me
the
like you have
plots
written APIs
in Python, yeah.
and you create and you call it Bokeh.
There
right?
is
Right?
yeah, and there is also so there is a new JavaScript API directly. So if you also just wanted to target the JavaScript API, this is very new, so I don't have a lot to show you about it yet. But
So this is a question because if I don't want to rewrite all of this, but I just want to license and use this API and use it on iOS without, of course it's faster, it's better in the native language.
Yeah.
etc. But at the same time, if I don't want to do all of that,
so are things updating? I mean, or is it a case you can sort of generate the plot once and then it's sort of fixed, or you need to update things?
yeah, you need to update.
Okay. Let's have a discussion after. Let me get started on this. But yeah, please come find me. Let's have a longer discussion right after the tutorial. Excellent. Great. This is a really interesting case, so I'd love to talk about it more. Yeah, excellent. All right. Welcome back, everybody. I think we're probably ready to get going for the next section. Hope everyone have a nice little break. 2 hours and a quarter is kind of a long time to sit, so hopefully that's good to stretch your legs. Okay, so we saw how we can take these Bokeh plots that we can create, we can put them in layouts like grid plot or whatever. There's also let's see here. There's also something called column. Let me go ahead and show that off right quick as well, just before moving on. So in addition to grid plot, there is row and column. And so you can do things like row. And here I can just give a list of plots. And that's just an easier way to generate a row. Note that, again, the toolbars there are not collapsed. Column also here will generate a column of plots. So there you go. Anyway, so the next thing though, the reason that this is nice sort of setup is that we want to talk about how to have linked interactions in Bokeh plots. So there's all kinds of things you can do using the Bokeh server or callbacks that we'll see pretty soon here, but it's actually possible to do a lot without writing any sort of code, to just do things very declaratively. Want to make it very easy in Bokeh to have things like linked panning. So if you pan one plot, another one can move correspondingly, or linked brushing if you make a selection on one plot to see the corresponding things linked. And so those are very easy to express in Bokeh. And so you do that by sharing things, basically. So let's talk about linked panning first. Let's say we want to have some plots that work together. And then if we pan one, then we see the other one's pan as well. So here I create my grid plot. But what have I done differently when I create these plots? So the plots have an attribute called X range and Y range. And these are normally created by default, by figure. And they're also created in a way that they sort of auto-range, to whatever the shape of the data is. It tries to sort of show all the data at once. And that's the default. But it's possible to share ranges between plots. So look what I've done here. On my second plot, I've set its X range equal to the X range from the first plot. And I've also set its Y range equal to the Y range from the first plot. And for the third one, I've only shared the X range. I haven't shared the Y range, but I've given it the same X range that the first plot and the second plot has. And so if I execute this code and I run it, what's going to happen? Well, the first two plots are linked in both axes, whereas that last plot is only linked in the last axis there. So it's very easy. So I mean, there's all kinds of other additional interactions that we can do. We'll see in a little bit where we can use like custom JS callbacks, or we can use Python callbacks in the server. But getting this kind of basic linked interaction is fairly straightforward without writing any actual code to do it. We just, if we want to share axes, we want to share this panning, we can just share the ranges that control that direction. And it's very easy to do. Same thing if we were to zoom in and out, we would see the zooming behavior behave the same as well. Okay. All right, so exercise here was to create two plots in a grid plot. Let's go ahead and do that. So if we do from Bokeh, and I'll let everyone here do that as well, but plotting, import figure, and from Bokeh.io import show, and from Bokeh.layouts import grid plot. All right, so I can say something like P0, this figure. Let's give it a plot width, 250, and a plot height. And we'll want P1 to be pretty similar to that. And let's do P0.circle. Fake data there, and we can do the same thing for P1. Right, and then we put those in a grid plot, right? Layout equals grid plot. And I want to share the ranges here. So here, let's just share the X range and not the Y range. So we say something like X range equals P0.X range. And then we want to show the layout. What did I forget here? Oh, I misspelled grid plot. And not P2, P0 and P1. Great, and so if we actually look at those, then sure enough, they share the X range. And so we have that linked panning behavior on the X direction, but not on the Y direction because we didn't share the Y range. Any questions about linked panning? Or that kind of linked interaction? We'll talk about how to do other things in reaction to sort of pan or range change events too. There's this whole notion of adding sort of short, small custom JS callbacks, and you can attach those to, for instance, range changes, so that when the range changes, you can do all kinds of fancy things. So next, though, linked brushing. So linked brushing is really the idea that you want to highlight things in a similar manner across different plots. So in particular, if we make a selection on one plot using a lasso tool or a box select tool or something like that, can we highlight the corresponding points, data points in another plot? And again, Bokeh makes that very easy to express by just using a sharing notion, right? So under the covers, the fundamental sort of most common data transport structure that Bokeh uses is something called a column data source. This is sometimes a source of confusion. I'll say sort of very simply that it's a fairly basic data structure. It's basically a dictionary that maps string names to sequences of data. It's kind of like a cheap data frame, right? We didn't want Bokeh to depend on pandas at the core level. We wanted to make it sort of as dependency-free as possible. And we also had some other reasons as well. So we made this column data source, and again, it's just basically a dictionary that has sort of named columns, and the columns have to be the same length, and that's it. So we can create that ourselves. We haven't done that yet, but let's do that in this example. Let's take a look at it. So I import column data source from Bokeh.models. I create some X data and some Y0 and Y1 data. Again, it's just Python lists in this case. We could have NumPy arrays, pandas columns, whatever we want. I create my column data source object, and here it's exactly what I says it is. I create a dictionary, and I can set the X key equal to the X column of data, and the Y0 key equal to that Y0 column of data, and the Y1 key equal to that Y1 list of data. And so this is just actually, let's go ahead and split this cell. If I go to, we can take a look at it. If I split the cell and I execute this, and then I say something like print source.data, right? You can see exactly what it is. It's a dictionary that has a list of data for Y1 and a list of data for Y0. It's a very simple data structure. That's all a column data source is basically this with some other things around it. So we can create those explicitly, and if we do that, then when we create our glyphs, we can tell it specifically, I want to use this column data source or that column data source. So first we're going to go ahead and create a plot. Someone also asked earlier about specifying tools. Here's one way that you can specify what tools a plot should have, right? I just give it a list, sort of a comma-separated string that says I want a box select tool and a lasso select tool and a help tool, and I can pass that as the tools argument to figure. So that's one thing there. So I create my figure, and then I call circle, and instead of giving it the actual, list of data here or array of data here, I give it the name of the column that I want to use. So I want to use the X column for the X value and the Y0 column, and I want to take those from my data source that I created up above. And so I pass the source argument to figure as the data source that I just created up here. Let's actually rename this, make it a little bit more obvious. So I'm going to call that DS. So I can say source equals DS and source equals DS here. And the thing to note is that I've given both this left and right plot, I've given them the same data source. So if I have two plots that share a data source, that means that by default, selections on one will be mirrored as selections on the other. And so let's take a look at what that actually looks like, right? So here I've got my two plots. I can create my box select tool. I can select these points, and sure enough, the selection automatically is mirrored in the other plot. Now, sometimes you have more sophisticated things where you have like one-to-many selections, and we can sort of see some examples of how to do that with custom JS callbacks. But if you have data shared between plots like this and you want to just have the selections mirrored, it's very easy to do, again, without writing sort of code to do that. You just share the data source, and that just sort of falls out naturally. Okay, so yes? No. Yeah, so basically the way that the transport works for Bokeh is that every model object is sent, and so in this case there's one data source that's shared between objects, and this was a little bit of a fun implementation challenge. We had to basically create something akin to pointers in our protocol that could be used to create an object once on the JavaScript side and then actually share it among multiple plots, for instance. But that's, yeah, in this case, the one data source is sent, and then that's the reason it works, is because it's actually shared between the plots. So if I make a selection here, it doesn't matter. If I make a selection on this side, it's mirrored on the right side. The two plots share those data sources. So we wanted to make that kind of interaction very easy to express. More things as well, but okay. So I do actually want to get to the fun stuff. So let's go ahead and skip this exercise if that's okay. I think hopefully everyone has a pretty good idea. Another nice interaction that's fairly easy to spell in Bokeh is to have sort of interactive hover tools for sort of drill down. You know, as I mentioned, when you create your own column data source, you can give it, you know, the columns of data that you want to drive, for instance, the coordinates, X or Y. You could create a column to drive the fill colors or the, you know, the line widths or whatever you want. But you can also put in extra data that doesn't actually correspond to anything on the glyph. And the reason you might want to do that is because you might want to have a hover tool that can show data from that column. So let's take a look at that concretely. Here I create a column data source. Again, I give it my dictionary here. I've got some X values, I've got some Y values, and then I've just got some other column called description or desk. And it's just got some strings in it. You know, it could be part numbers or tags or something, whatever. It doesn't actually, it's not actually used to draw any of the glyphs in Bokeh, in the plot, but we want to be able to use it to sort of maybe show up in a hover tool. So what does that look like? So we actually create a hover tool. Again, I've imported hover tool from Bokeh.Models. And I can pass it this tooltips. And the way tooltips works is you give it a list of tuples that have a sort of a field name, and this is what's going to show up in the tooltip, index, X, Y, and desk. And then I can refer to columns. So if I want to see the corresponding value from that description column, I can say at desk. There's this little language that's described in the docs. You know, at foo shows whatever from the foo column, right? So in this case, I want to see the value from this description column in the hover tooltip. So I create my plot, give it a title here. I say that, you know, the circles should be at X and Y. I want to give it this data source I've created, and then I hover over that. And sure enough, I think we got a little CSS issue master I need to fix. I'm not sure why those sort of table lines are there, but you can see it's got the description, right? For every one that I'm hover over, I've got the corresponding description showing up. Right, so this is point A, you know, this one over here is point E, and so we're able to have these nice columns. It's also possible to have a custom hover tooltip. Basically, you can supply a template, an HTML style template, so if you want to have sort of a more fancy tooltip, you can definitely do that here. In this case, we've actually got a column that loads an image. You know, the tooltip actually has an image in the template, and so you can actually have images show up. We aren't quite at the level where we can have a Bokeh plot in the hover tooltip. Someone asked about that recently, and I sort of made a stab at it. That would be really awesome, I think. We're not quite there yet. That's probably something we can do pretty soon. But anyway, so this is the hover tooltip. You can use that to be able to hover over all kinds of things. You can see more examples of that in the docs. If we go to bokeh.pydata.org, we can go to the user's guide, and there's a whole section on adding interactions in here. And so if we go there, we can go to, let's see, linking plots. Where would that be? We just reorganized this, sorry. Actually, I think hovers are going to be under configuring plot tools, sorry. Configuring plot tools, yeah. So here we have, you know, the hover tools, and we can talk about, you know, basic tooltips as well as, you know, here's what a custom tooltip looks like. It's basically just HTML that has, you know, things like, you know, at whatever column I want, and it just shows up. So also, if we go to the gallery, I think there's an example in there as well. Another thing to mention, so in addition to the user's guide and the reference guide, by the way, there's also a gallery which I would like to start adding. We have some new examples that we haven't added here yet, but it's still quite good at the moment. We're going to be adding more to that as well. Idea is, you know, people learn in different ways, I think, and so sometimes, like for me, I just go look in the gallery and say, hey, what looks kind of like what I want, you know, and I go find it. And then I can sort of see the code. And so all of these are live. You know, this is an example of showing those jitter transformations, and so you can sort of see an example. Hover works with things like patches, right? So here's a map of Texas and some unemployment from 2009, and you see it's quite snappy on those the counties of Texas, right? So anyway, good stuff. All right, there we go. So that's hovers. Another type of interaction you might want to do is in the Jupyter notebook itself. So in addition, so Bokeh has basically a set of built-in sort of widgets you can use, and as we've seen with sort of custom extensions, you can wrap other JavaScript widget libraries if you wanted to. Jupyter has its own set of widgets that are built in, and so we can actually use those really well with one particular function called push notebook that lets us update a plot in place. And so let's take a look at what that might look like. So here I've got my standard imports. I'm using NumPy to create some X and Y data. I put that in a column data source. I create a figure. I create a line with X and Y. I give it the source here. And now here's what Python or Jupyter does, right? I create this function called update. It takes an argument, which in this case is going to be a string, as well as sort of an omega and an amplitude here and a phi to control the parameters of a sine wave here. And you can see what the function does. If f is sine, then it computes a sine. If f is cosine, it computes np.cosine. If it's tangent, it computes np.tangent. And then what it does is it computes new y values for whatever the parameters that got passed update. It computes a whole new set of y values, and it sets that to source data. So source data sub y, it's my y values. It updates them, and then it calls push notebook, and that's where the magic is, right? So push notebook is what causes the inline plot to update. So let's go ahead and run this. I want to show my plot. And then the last little bit here, this is from IPyWidgets. So IPyWidgets is a separate library outside of Bokeh. It's sort of part of the Jupyter project. I want to call interact. And so when I call interact, I want it to use my update function. And then I get a list of all the values. Here's a list of the values for a dropdown. Here's a list of slider values for the W, A, and phi things. And when I run this, Jupyter just automatically creates this little GUI for me. And sure enough, if I change this W, then the plot updates, right? Or change the amplitude, or if I change the phase there, or if I select cosine, then it's going to give me the cosine or the tangent or whatever. And so again, the magic that makes this happen is in my update function, I'm able to update the y values in my data source, and then to actually have the same plot that's already drawn get updated in place, I call push notebook. And so this doesn't redraw the entire plot. It just causes, or recreate the entire plot. It very efficiently just sends this one set of data that changed, and then it causes the redraw to update the actual line that's drawn there. So that's a really nice sort of capability. If you work a lot in the Jupyter Notebook, this can be very useful.
So the old data is destroyed.
So what is sent is basically like a patch message that says patch the data source with this new column, and it gives the new y values. So I don't want to go too much into the sort of the low-level details, but there's basically a protocol that can support updating attributes on these models. And so in this case, you can say, I want to update the data attribute. And so it sends this data attribute over, and it replaces the data value. But everything else that was previously sent, all the axis objects, all the plot itself, the tools, none of that has to be recreated. It's just the data.
So there's not growing some column or data, JSON, it's not growing.
Yeah, exactly. Right. Yeah. The idea is that we're just sort of patching just the part that changed, right? And so push notebook can keep track of what changed and send just that bit that changed. Okay. So again, that uses this IPyWidget. So if you want that to work, you'll also need to conda or pip install IPyWidget. So I think I forgot to mention that earlier on. This is the one example that uses that. But the main thing there is this interact function. So you give it a callback, and then you give it basically what you want all the parameters for that callback to be represented by. So a list of strings is going to give us a dropdown like this, whereas tuples like this are going to give us a slider. And you can see that it's got a slider for W, A, and phi. Because we gave it tuples. And then whenever you change the slider, it will call that update function for you. So that's how that sort of all gets put together. Okay. So as I mentioned, Bokeh also has its own set of widgets that you can use either in the notebook, but you can also use in Bokeh applications or standalone Bokeh documents outside the notebook too, right? So that's the main reason we created our own widget sort of collection, is because we wanted to have more kinds of widgets than are offered by the Jupyter Notebook, but we also wanted things that could work outside the Jupyter Notebook, and so that's sort of an important thing for us. So let's take a look at what that looks like. Let's say we want to create our own slider. Excuse me. So I import slider from Bokeh.models.widgets. It has the kind of parameters you might expect: a start and end value, start and an end point. It's got a value where it should start, a step size, and maybe a title. I'm going to put this in something called a widget box, and then I'm going to show that, right? And so that's going to give me the slider, and sure enough, I can just see that I've got a slider. And by itself, it doesn't do anything. It just creates the slider for me. I haven't hooked it up to anything. We'll see in a bit that we can hook it up to both Python code using a Bokeh server, or we can hook it up to little tiny snippets of JavaScript using custom JS callbacks. So we'll see that in a second. We'll go ahead and refer everyone to this adding widgets section in the user's guide. And if you do that, you can see lots of different, basically all the kinds of widgets there are. You can see examples here in example code. So let's take a minute to actually do an exercise, and then we can add what did it have us add? It was a select widget, right? So we'll take 2 minutes. We'll add a select widget. Yes, the question is about communication between widgets. In the standalone document with custom JS callbacks, basically whenever the widget is updated, that triggers a JavaScript callback that you can supply. And in the Bokeh server case, it's basically any property change can trigger a callback on the Python side. And so you could have the same callback for multiple widgets if you want that. But when you scrub the slider, that causes like the value property to change. And so then that will trigger a callback in the server code.
I think more like cross-filtering, you got multi-hierarchical selects. Select one and then the options drop.
Oh, and you want to change, yes, yeah, you want to change the options in another. Yeah, you can certainly change the options in one widget based on the other widget. You'd have to write a callback that does that, yeah. But yeah, you would say select two.options equals some new list of options, and then the act of doing that would cause the other ones to update. Yeah, very good question, okay. All right, so I'm just going to copy this select code here and then we can talk about it. Exercise here. So again, I've imported widget box and I've imported select. I don't want to do output file. Select takes things like a title, an initial value that you want, as well as the options. So here I've given it, foobar baz quux, and if I do that, sure enough, I get it, and I've got my widget. So again, what can we do with these widgets? That's great. We can create these widgets. Right now, they're not hooked up to anything. They're just sort of there. So if you actually want to do something interesting, again, the two ways, and we'll see both here before we leave today, are custom JS callbacks and the server. So let's quickly go through some custom JS callbacks, and then we're going to sort of pivot over to talk about the Bokeh server. Okay, so here is a canned sort of custom JS callback. There's something called, well, actually, sorry, I lied there. Here's a custom JS callback, and I give it some JavaScript code. What is the JavaScript code? It just says alert, hello world. I'm attaching this callback to a tap tool, and so what that means is that whenever I get a tap selection, it's going to call this little bit of JavaScript, right? So if I do this here, sure enough, right? I clicked on a circle. Whenever the selection happens from a tap tool, that's when the callback gets called, and it calls, alert, hello world. But we can imagine doing a lot more interesting things. So there's actually a lot of places to put callbacks on. You can put them on basically any sort of widget change. If a slider is scrubbed or if a dropdown changes, you can put them on lots of tools like box select tools or lasso tools or hover tools. You can put them on selection. So when the selection changes on a column data source, you can do that. And finally, you can put them on ranges. So if the range, if the pan or zoom and the range changes, you can respond to that as well. So if we actually want to take a look at one that has a widget, let's run this code and then I'll talk about it. Right? So here I've created in a layout, I've created a slider as well as a plot. And if I scrub the slider, we can see that sure enough, the Y values for this update, right? So what's going on? So how do we make that happen? So this is a little bit of a compromise. I originally said at the beginning, no JavaScript, but we did realize as we were still working on the server and we wanted to allow people to have capability that, if you're willing to have a little bit of JavaScript here and there, you can actually do some really interesting and sophisticated things. And so this is an example, you can do with, 5 or 6 lines of JavaScript. You can make standalone documents that are just HTML and JavaScript, no server, that are still quite richly interactive. And so what do we do here? So again, I create some data X and Y. I put that in a column data source. I create a plot with a line. All of that we've seen so far. At the bottom here, I'm creating my slider. I put my slider and the plot in a column, and then I show that layout. So that's everything we've seen so far, nothing new there, except now you know that you can put both widgets and plots inside these layout functions, right? So we can, before we only put plots in the layouts, but now we can also see that it's perfectly fine to put widgets there. So what actually makes the widget do something? Well, I create this callback, this custom JS callback, and the code that I want to give it, well, it says, okay, I want to get the data attribute of my source that I passed in. I want to get the value from whatever the callback object was. In this case, the callback object is going to be the slider itself. And so this gets that value. And then it gets the X and Y data, and then it loops over it, and it just calls math.pow, right? So for whatever each X value, it calls math.pow with the value of the slider as the exponent. And then it calls this source.trigger.change. And there's actually a new section in the user's guide that explains a lot of what's going on here in the JS API. But hopefully it's at least roughly sort of in general form apparent what's going on here. And sure enough, when I scrub the slider here, the values for Y are whatever. So this is if I go to 1, I get a straight line because it's just X to the 1 power. If I go to 2, then this is actually a bit of a parabola, right? It's going to be X squared or X cubed or whatever. So yeah. So anyway, that's affords a lot of different capabilities there. As I mentioned, it's also possible to have callbacks on selections. This one's a little bit more sophisticated. I'm not sure I'm going to go through it in a lot of detail, but what it does is whenever you make a selection, it computes the mean value, the mean Y value of all the selected points, and then it adjusts the data source for that orange line. So I can, see that the line will update, to whatever that mean value is. So you could imagine actually having to do something more sophisticated to compute a regression or something you wanted. This even works for distributed or disjoint selections, right? Might do that. But the code is up here. It's a little bit more sophisticated in this case. It has to look into that selection object and get the selected indices and then compute this median right here.
So within a notebook, if you're running a server, is there still an advantage to this, or is it just for embedding something standalone? You still want to write JavaScript if you're having a notebook running?
Yeah, people definitely do. It just depends. So right now we're still currently working on improving the interaction of the Bokeh server with the notebooks. So now you have two servers, and so we're still working on making that a little bit better, I think. But people have definitely done a lot of interesting things with with custom.js callbacks in the notebook. In particular, the data shader example I show where the custom refinement or the progressive refinement happened when I zoomed in on those 10 million points. That's due to something like this. Basically, it sort of makes a full loop. There's actually a custom.js callback that calls the Jupyter JavaScript API to execute Python code, which causes the recomputation to happen on the Python side. But it works. It works really well. So it's possible to do a lot of interesting things. And so one of the things, though, is that it's possible to encapsulate this. The ability to make those custom extensions means that we can actually do this and not necessarily have the JavaScript code here, but we can have it basically sort of in an encapsulated form and say you create your own model for some new fancy widget or fancy tool, and then you just use it like any other Bokeh model. You can add your custom tool or your custom axis, and it does something special, and the JavaScript code is sort of hidden. And again, those kind of extensions, I want to make them really easy for people to share. If you think of, like, again, the Atom extension sort of browser where you can load community contributions into Atom, that's exactly what I want for Bokeh, because I think it'll really multiply and amplify the value of those kind of extensions if the community can share them very easily. So that's on the fairly short-term roadmap for me to get done. If you actually go to the documentation in the user's guide, there's quite a few more examples. So I'll scroll up here to the user's guide, and we go to configure plot tools, working in the notebook, adding interactions. There we go. Right, so we go to JavaScript callbacks subsection here, and again, there's just a lot of examples here. So there's the one we just saw. There's also just one here, sort of on a custom tool that just draws. I want to draw a bunch of rectangles. So someone else recently on the mailing list came in and had some really cool use cases where they'd written a custom tool to let them annotate things. So they had a plot of something and they wanted to be able to select some region and then have that inform some other further computation. So that's exactly the kind of thing we want people to be able to do. And so they didn't, they wanted to have a standalone document, and so they used custom.js callbacks for that. Here's another example. It just copies the selection from one plot to the other, but you can imagine doing something quite a bit more interesting, if you do whatever. But here's that same example with that. Custom.js for hover, right? So here, we want to have this sort of many-to-one relationship. We can do a callback on a hover that can sort of draw the lines just when I hover over it, right? This is something more sophisticated than you can do with just the hover policy, right? Because we need to draw these multiple lines for the hover, but the custom.js callback would let us do that. Range update as well. Here, if I zoom in to this plot, I can sort of show in the other plot here, where I'm zoomed in. By the way, when I'm zooming in, you might notice that the plot gets decimated. That's something called level of detail downsampling. It's also controllable. Basically, it's just while interactive events are happening, it'll downsample the data automatically so that the response rate is sort of kept up to date or kept efficient, so that it's very responsive, right? So anyway, that's an example of what you can do. You can have callbacks on those. Last thing to mention here, this is kind of cool. Almar Klein added support for this. It's actually possible to write the callback code in sort of Python for custom.js callbacks. He has a transpiler, Python to JavaScript, and it's a little weird because you always have to bear in mind it's not running Python in your browser, but it's compiling this Python or transpiling this Python to JavaScript. And so here I've actually written the callback in Python, and you can see exactly what it does. It just, math.pow, and then I call this custom.js from Py function, and I give it the callback, and it actually just generates it. And that generates a custom.js callback. It generates the JavaScript. I have mixed feelings on this. It's really cool and it's really awesome, but you also do have to remember that it's not quite Python, you have to know, for instance, that I need to call window.math.pow because that's the actual JavaScript function that has to be called. So it's, transpilation's a little strange sometimes, but it can be useful and people will certainly use that as well. So, okay, so making sure we have time to talk about the Bokeh server. I think that's the end of that section. But before we start,
How do you call REST API or whatever from context selection? Is that part of the custom callback?
I mean, so you can put whatever JavaScript you want in the custom.js callback. So if you wanted to make an AJAX call, you could. I haven't done it personally, but
Well, just like selecting text point and go fire out some jobs.
you absolutely could. Yeah, I think so. I haven't done that myself, but I don't see.
Context of
Yeah, you would construct whatever AJAX, in the callback you would construct whatever AJAX call you need, and you would presumably give it the callback when it returns, and then you could have that. I think that would be not a problem at all. I haven't done it myself, but yeah, very cool. Okay, so before we dive into we're going to skip ahead to chapter 8, see if there's any questions. Just to give a mention of sort of what we're sort of skipping, there are APIs for sort of embedding. And if you want to have a Flask app or a Django app and you want to have a static standalone sort of Bokeh document embedded, there's a lot of functions for doing that. There's a section on the low-level Bokeh.models that really goes into more detail there. Annotations, there's some new annotations that have been created. Things like, if you want infinite, span lines or box annotations, there's also new labels that have come in. And again, that LaTeX label is sort of a custom model that was created. You can use label set to easily label points like this. Arrows, another new one, just added I think in 0.12.1. Luke Kahneman worked on that. So that's a whole section there for adding annotations. But then what we really want to talk about today is sort of Bokeh applications, right? And so that's what we're going to do. So last chapter we'll talk about today. Any questions before we dive into the Bokeh server chapter?
Just on the custom.js, so if you export that to Django, like you were saying,
Mm-hmm.
you do custom.js on that side of the Bokeh app, so you set up
Yeah, I mean, anything you can access, right? So I mean, if you're, if you know how to get a hold of that object in the DOM using jQuery or whatever, then absolutely, yeah. Okay, good. All right, any other questions? The question was, can the Bokeh custom.js callbacks, access other elements on a page? And again, whatever you can get a hold of, you can manipulate however you want. It's just JavaScript, right? Yeah. Okay, other questions? Excuse me. Okay, so let's just dive in. We're going to talk about the server. First note here in bright red is that these exercises are actually outside the Jupyter Notebook, right? So this is going to require copying and pasting some code into a file, and then we're going to run a Bokeh serve command on that file. And I'll talk about that in a bit, but just so you know, these are sort of the codes here in the notebook, but we'll actually have to run them outside the notebook, and I'll show that in a second. Okay, so what is this Bokeh server supposed to do, right? So I mentioned that the way things work is that we have this Python representation of things, these objects we call models, axes, grids, data sources, the data, the glyphs that we want to show, the tools, the toolbar, whatever. And then basically there's a one-to-one mapping between all of those objects and a set of JavaScript objects. And the way we connect those is there's this JSON protocol. And so we turn all the Python, serialize it into JSON. Bokeh.js consumes that and then recreates all of these objects, these real objects, and that's what does the work to actually render the plot and do everything in the browser. So that's really nice and fantastic. And again, that decoupling affords us the opportunity to have things like RBokeh and Bokeh.Scala or Bokeh. I keep threatening to write a MATLAB binding for Bokeh, but I haven't had a chance to do that yet. But any language you would care to write a binding for, you could, if it can generate the right JSON. And so that's really powerful in and of itself. But what the Bokeh server, what its purpose is to do is we want to be able to create these documents with these models in them on the Python side, on the browser side, and be able to keep them in sync automatically. So if I make a change to the Python object, like I change some data or I change a range, the plot updates automatically. The UI updates automatically. And if I have some event that happens on the browser, if I make a selection or if I pan the plot or if I make a selection from a dropdown or some other widget, I want to be able to have Python code respond to that. So I really want to have real, true Python code executing, right? So I can't call pandas in my custom JS callbacks because pandas doesn't exist in the browser. I'd love to have a JS version of pandas, but that doesn't exist. So With the Bokeh server, though, I can have a callback in Python that runs in the server that actually does call pandas and does some real work in Python in response to a selection or into a widget or whatever. And so let's take a look at sort of how that works. So that's the main purpose of the Bokeh server, to keep things in sync, to keep the Python side, the JavaScript side completely in sync, right? So the bidirectional nature of this allows us to do some really powerful things. So let's take a quick look. So let's start out with the sort of hello Bokeh example here. I'm going to copy. Well, let's take a look at the code, and then I'm going to run it. So typically in Bokeh applications, you need to import something called curdoc. This is the current document. Right? So the current document is the thing that holds all of these models. It's just a big collection. I want to put all of my things that I'm going to create in a column. And what I'm going to create is a text input widget, a button widget, and a paragraph. Note, I'm not actually even going to create a plot here. It's not required. So that's actually something that surprises people sometimes. But you know, we can keep whatever we want to keep in sync, and if it's just widgets, that's perfectly fine. So the button, we just have a button that says say hi. We have a text input widget that starts by saying, you know, Bokeh. We have this empty paragraph widget that we're going to add. We're going to put all of those in this column. So we have the button, the input, and the output in a column. And then also typically we're going to call something called add root. So on the curdoc, we call add root, and we add our layout. Now, what actually puts things together is right here. I have this function update, and it says, it changes the text property of my output box to be hello plus whatever the value of the input box is. And then I set that as my callback. I say button on click, call this update function. Okay, so I can take this code, and I can put it in a text file. Let's see if I can get my thing to leave full screen. Okay, we'll go over here. So here if I go to, I think the temp directory, was apt. Okay, well, we'll go there here. If I go to my temp directory, and I also want to activate my PyData conda environment, here I have created hello.py. Is that font? Let me make that bigger. So this is just that code copied into a text file, right? I just copied and pasted it from the notebook. And the way I run this is I'm going to call the Bokeh command, and I want to serve this, and I actually want to open up a window as well, so I'll call Bokeh serve-show, and I want to call hello.py. And when I do that, I get this running application. And what happens? Well, if I say hi, it says hello Bokeh. If I say hello PyData San Francisco, I get hello PyData San Francisco. So again, just a couple of lines of Python, right? You know, I'm able to have this sort of nice web app that's driven by whatever in the PyData stack that I would care to use, right? If I want to call, you know, anything, pandas or NumPy or whatever in that callback, I can, and I can connect this web app to, you know, to that powerful Python ecosystem, and I can create as many of these as I need to, right? So obviously, the amount of work that the app does is going to dictate how many. You know, as if I want to scale these kind of apps out, it depends on how much work the app does as to how many, you know, Bokeh servers I would need to run. But every time I hit this URL, I get a new one, right? And so there's this many connections running, and I can say hello, PyData again. And so all of those are different, right? Every session gets its own. And so again, this is what happens when you go to the demo.bokehplots.com site and you look at the apps that are hosted there. There's actually, I think, something like 16 Bokeh servers running. We just ran a bunch of them on some EC2 instance behind an Nginx, you know, load balancer, and so we can have pretty much as many people hitting that as we need. Yeah, question? Yeah, so there are options to control things like timeout if you want the session to timeout, or as soon as the you know, the connection's closed, the session gets terminated after some timeout as well. There are some additional features that I want to add that are not there yet, but I'm hoping to add in the near future. For instance, things like some busy messages. So if you're doing something that's sort of long-term and blocking, right now there's not a great facility for sort of indicating that with like a spinner or something. That's a pretty easy addition to our protocol. But also if we want to have things like reconnecting sessions, that's right now you would get a new fresh session every time you reload this page. Or forcing reload is another protocol message I want to add. But right now, again, you can control the timeout explicitly. You know, if you want to set some maximum timeout, and of course when the connection's closed, when the tab's closed, it'll time out after that as well. So this is actually, so yeah, so it's run in Tornado, and so there's not an active kernel. This doesn't use like Jupyter kernel, there's just a Tornado app. And so if you have, If you have things that are blocking, there are ways to use, for instance, threads to offload that work. And well, I'll show where the documentation and some examples of that are. So the key is, since we're using Tornado, which is this asynchronous framework you might have seen in the last talk, you want to make sure that the Tornado handlers respond fairly quickly, right? And so a lot of things that's perfectly fine. You'd be surprised what responds really quickly on a sufficiently beefy box. But if you're doing something that really takes a long time, like calling out to sklearn, you'd probably want to use some of the threading techniques, which I can point people to actually have that happen and then update a little bit later, because you don't want to block for too long. Okay, but yes.
So if somebody does a long call, all the other sessions will have to wait.
If you're only running one server, so that's one reason why, like I said, there's sort of a curve of amount of work that any given callback does versus how many Bokeh servers you might want to run. And so the nice thing is that the Bokeh server is very horizontally scalable. If you need more capacity, you can just run more of them. And so, for instance, there's documentation on how to run them behind an Apache load balancer, behind an Nginx load balancer. If your server's like this, I don't imagine there's any number of connections. Like this could handle any number of connections, right? Because it's not really doing any work, right? But if you wanted to call out to like sklearn, where it was doing really real work, you probably would want to use some of the threading techniques that I can sort of point you to documentation in a second. And if you didn't, then it would block a single server. And so that's just the nature of Tornado. But.
What's the layout? Is it all into or?
Yeah, so right now this is just an auto layout. We put them in a column, but it is possible to use a custom template. So if we go back to, we go back to Bokeh, demo.bokehplots.com. We go back here. This one is using a custom Jinja template to sort of place things more sophisticated, right? Or actually, I know the one that really uses this one right here uses a custom Jinja template. So the actual YouTube embed is in the template, and then the Bokeh application is just sort of embedded here in the center. And I think all this text is in the template as well. So if you're in the realm of like a single page app, you can just run it directly from the Bokeh server. Obviously, if you have a more complicated sort of site, you can embed these Bokeh applications in a variety of ways into like a Flask app or a Django app or a Pyramid app or whatever. Okay, cool, good questions. So let's take a look at the next example. Any questions about that first? Okay, so let's actually take a look at, we're running out of time. So here the exercise was to add another widget here that adds some more examples. Let's see if we can do that maybe right quick. Let's take a few minutes, and if people want to play around with that, you can. Otherwise, I will try to add a select box as well. Let's go up here. So I'll have to remember the syntax. If I go to widgets, I'm going to add a select.
So all the widgets that we're generating or writing in Python, are those the logic running in Python too?
No. Well, so the callback is running. When the value changes, that calls. But the actual implementation is wrapping some JavaScript widget, right? Our default widgets, I think, are just fairly bog standard, like some Bootstrap widgets. But you can actually wrap any JavaScript library you want. One of my colleagues, Sarah Bird, just is working on a client project and wrapped the Ion range slider, which is a really, really nice sort of more sophisticated range slider with double ends and dates, and it looks really great. And so she wrote a custom extension that basically adapts, this JavaScript API to whatever the Bokeh properties are on this model, and it just works out really nicely. You don't have to write much code to do it, but if you have, if you want to wrap like Leaflet, or I did wrapped Viz.js, or if there's some really cool, other JavaScript library that you want to connect, to scikit-learn or to Pandas, this is the way you can do that. There's the Bokeh server, sort of that bridge that lets you connect the PyData stack to, arbitrary sort of whatever JavaScript capability you want.
Is it just JSON that comes back from the front end after change, or is that custom depending on the traffic?
So between Bokeh server, between the Bokeh application in the browser and the server, there's a JSON protocol, that's specified. Yeah, basically it's all of these models have properties, and the properties have types that are specified in Python. In fact, that might be instructive to look at right quick. If I actually look at, what does a Python model look like, take a bit of a diversion here. And I go to Bokeh, and I go to models, and I go to, let's look at, ranges, and then I want to look at a range 1D. almost all the Python models are very declarative. They have these traits-like things. So a range is a start and an end is either a float or a date time or an int, right? And there's no actual code here, and so these are automatically serialized in the right way for the protocol. This also plugs into our documentation really well. It also validates. If you set start equal to like a string, you'll get a nice validation error that says, hey, start has to be a float or an int, or a date time. Similar for a data range here, you can give it a list of names of renderers, right, to actually do the auto ranging over. By default, it uses any render that it can find, but if you want to restrict it to a certain set of renderers, you can give it a list of the names of them or a list of the renderers themselves. Bokeh.JS matches these exactly. In fact, we have tests that make sure that the Python models match up exactly to the JavaScript models in terms of what their properties are. And so the protocol is actually for updating these properties between Python and JavaScript models. Yeah, and so the way you write a custom extension is that you adapt whatever the JS API is to some set of properties on some model that you create. Yeah. Good questions. Okay, I'm glad we got to talk about that. Let's see. We are running a bit low on time. Let's skip this exercise here. I was going to add a select box that just had a bunch of different greetings, hello, bem-vindo, and aloha, whatever. But that would be adding a select box and then adding that to the callback to use the different greeting instead of hello, right? So, but let's go ahead and move on to the second example here, where we put some plots together. So again, let's take a look at the code, and then I'll run this example. So again, import some NumPy. We import curdoc is very important for our server applications. In this case, I've got rows and columns. I'm creating a column data source and a figure, and then I want a select box and a text input. And so I create my figure. I add some circles to it. And I've got also a select box that has a list of colors. In this case, it's going to be things like, where's my list of colors somewhere? Yeah, black, firebrick, navy, olive, goldenrod, right, colors. And then the text input just has the number of points as the title. In this case, I'm going to start with 200. Whenever the update, whenever the select box is changed, I'm going to call update color, which calls that glyph and sets its fill color to whatever's in the select box. Whenever the text box is changed, I'm going to call update points, which recomputes the value. It calls this get data function for endpoints, and it sets the data equal to that. Right, so I'm updating the .data attribute of my column data source, and just the fact that I do those, right, causes the change to be mirrored. So when this callback is called and source.data equals some new set of data, new data dictionary, that automatically gets mirrored into the browser and causes the update in the browser. So finally, I put all these things in my my layout. I make a row with my widgets, and I put that on top of the plot, and then I can call again add root. Typically, one of the very last things we do is call add root. And then we can run it. So let's take a look at that. So this one is now, I think I called it app.py. Right? So great. So maybe I want to change the color to firebrick. So I can do that. And my callback changes the glyph.fillColor based on that select box. And it changes all of the glyph colors. So I can pick any of these that I want. Right? I can say I want 2,000 points. And I get 2,000 points instead of or I want 20,000 points, right? Starts to look a little bit weird there. I didn't add any tools, so we don't see any of that sort of automatic decimation. But yes. Yeah, exactly. Let's take a look. Exactly, right? So what happens is I called input.onChange. Whenever the value changes, I want to call update points. So that change triggered this callback, which triggers this Python execute, which says I want to get new data for endpoints, in this case 2,000 or 20,000. And then it sets it to source.data. Just setting source.data equal to a new value, that's automatically detected and causes the new data to be sent, right? So there's no explicit triggering you have to do. That was an important sort of design consideration. So I should mention, this is actually the sort of the second generation Bokeh server. We had an original Bokeh server. It was a very different, and it was not very successful. To be completely honest. There are probably more people using this Bokeh server today than there were in the 2 years that the old one existed. I mean, literally today, in this room. It was sort of Flask-based. It couldn't do the performant things we wanted to do with sort of streaming updates or incremental patching updates efficiently. And it would also required like a lot of explicit triggering of updates. It was sort of fragile and error-prone, and also had like some classes you had to define. One of the things we wanted to really be able to do is just write a simple script. There's no class here. You could certainly use classes if you wanted to, but this is just a simple script, right? Simple script, I'm changing attributes on objects. There's no special classes I have to make. There's no explicit triggering I have to remember to do. It just automatically syncs things up, and that was a really important consideration. I should call out specifically, a lot of the work on the new server was done by Havoc Pennington, who, if you know, is one of the original authors of GTK and GNOME. He's tremendous work on the server, and very grateful to have had his help and assistance working on this. But anyway, yeah, so that's the main idea. So the new server, I think, has been validated just by the fact that there are lots of people using it and doing really interesting things with it. And it's been very gratifying to see that sort of uptake.
With that value call is what captures from the browser. Where's end? How can it send that?
It's the input.value, yes, exactly. So this says whenever the value changes, whenever the value property of the input changes, call this function. And so then it actually uses input.value, right? So yeah, so whenever it changes on the JavaScript side, that change is automatically mirrored in the server. Now there may or may not be a callback. The change is mirrored regardless, right? But I've said specifically if there is a change here on value, I want to call this function. And the function takes input.value and does something with it. Exactly. It's bidirectional. And that's why this all hangs together and works out really nicely, and why I think it's quite powerful. So, okay. So again, you could add more widgets to this. I'd actually like to show off some more examples. So I'm just going to go to the last example here, which is this streaming data example. So I think that's one thing that's been alluded to over here is that, if you have to replace all the data and you've got 20,000 points, that's kind of a lot of network traffic. There are certain cases where you can optimize that and do better, right? What if you're streaming data and you only need like the newest data point every time? You don't need to send all the data if you're just adding one more point to the end. So we recently added a .stream method to column data sources, so that you can specify, hey, I want to tack on new values to all the columns, 1 or 2 or 10 or however many, and I don't want to have to resend all the data. And so it's a much more efficient protocol. In this case, I don't go over the code too much. You can study it. I create sort of a circle, and then I create another circle, and basically well, let's just run it. Let me talk about it. The last thing I want to mention, though, is I create something called a periodic callback here. So in addition to callbacks based on models changing, you can add things like periodic callbacks. So in this case, I want something to run every 150 milliseconds on the server, and so that's what's going to happen. So let's take a look at what it does, and then I think it'll make more sense to talk about the code. So if I call stream.py, so this is adding a new point, and I've also specified a max rollover value. So as soon as it gets to, I think, 18 points, it just deletes it just starts dropping data off the beginning of the columns, right? And so that's, again, only sending, one value every update instead of sending all the values every update. And so this is just having the circle sort of rotate around, go around the circle. And so we could change, the value here if we go to vi stream.py. So yeah, the rollover is 18, but let's change the rollover to be like, 5. And now it'll start dropping data much sooner. So there's 5 points that sort of travel around. It just starts, as soon as the length of the columns gets to be 5, it starts, adding the new value and then dropping off the oldest value. Yeah, that has to be. Yeah. I mean, it's not impossible to do things like compute damage regions and try to do partial redraws, but that's a lot of logic and a lot of complication, and we haven't found it to be necessary, especially for a couple of reasons. One is that, one, the HTML canvas is actually really performant. I was kind of surprised. I've worked on other libraries previously. I worked on a library called Chaco with Peter Wang about 10 years ago, which was sort of a Python-rich client library. Used Cairo as a backend. I worked on another Cairo backend project maybe 7 or 8 years ago, and they were occasionally slow, but the canvas optimizations in browsers these days is just amazing, and it's been great. But in addition to that, we also have that level of detail downsampling that's possible to add. We also have WebGL support. So not every single glyph is possible to use WebGL support, but basically all the markers, lines, a lot of common glyphs, you can have WebGL support. So if you really want to draw 100,000 points on one canvas, you can do that, and it updates, and you can pan and zoom very fast. Once you get beyond that, you get into the data shader territory. Once you start to have millions or tens or hundreds of millions of points, that's where you start looking at data shader. Or you could write an app that does downsampling, I guess, is another option. But anyway, so we sort of have a range of capabilities across different data sizes. So in addition to the streaming, I should also mention an even newer capability, which I don't have a demo to show, unfortunately, but in addition to .stream, so stream is useful in the use case where you want to add new values to every column, just a few, and so you want to have to do that an efficient update. It might be the case that you just want to update a couple of values in the middle of some columns, just here and there. Like maybe you have, some columns that have 10,000 data points and you have 5 or 6 of those columns and you just want to update 3 or 4 things in the middle. There's now a data source.patch that lets you specify just a few values, wherever you want in the middle of a data source, and it will send just those couple of values. And so it's, again, a much more efficient than updating all the data. So, this is, again, trying to really squeeze more performance out of the Bokeh server. I'm actually really happy that we're still in a place where there's a lot of low-hanging fruit. Even as good as it is, another thing we haven't done yet, but that I would like to do in the next few months is a binary transport protocol for arrays. So right now we just sort of JSON all the things. But I had demonstrated a prototype where you can actually send a NumPy array directly into a typed array buffer in the browser without any kind of encoding. And so we actually already have a lot of the plumbing to support that. We deliberately wrote the protocol to support segmented messages, so you wouldn't have to do any copying of buffers to have things like that. We just haven't been able to get around to actually doing the last mile of that. But I think we're in a good position to have a lot of really great things. So that would just be sending the bytes. So well, we could. I mean, well. So the proof of concept that I did just sent numpy.asbytes straight into a typed array buffer, which is probably the absolute minimum amount of work you can do. Now, if you're running on maybe an SGI box or something that's big endian, I guess we'd have to talk about that, right? Maybe you want to turn that off, but yeah, it's not even. We could maybe use something like message pack to construct those binary buffers as well. But like I said, I did a quick proof of concept, and I just sent as numpy array.asbytes directly into the browser, and I got out what I wanted, and it worked great. So anyway, that's coming attractions. So last few things, just before we adjourn, a few more minutes, is I just wanted to show a few examples that aren't on demo.bokehplots.com, because there are a few newer ones. So I mentioned, in terms of streaming, one that's kind of nice is this OHLC demo. So I do Bokeh serve --show OHLC. So this brings up a nice demo that's basically streaming sort of indicators for financial data. It's got my candlestick chart. It's got the MACD indicator at the bottom. It's got a few sliders here. If I want to make a lot of money, I can move the mean way up, and that's great. Or if I want to have a lot of volatility, I can change the standard deviation. There's also different kinds of moving averages. Maybe I want a 12-tick exponential moving average, or a 26-tick exponential moving average, and we can change that. So just quick guess. The code, the script that I just ran has not only the code for the Bokeh plots, and not only the code for computing the MACD indicator, it's also got the synthetic tick data. It has the code to generate the synthetic tick data. Any guesses on how much Python code it is to have a web app that does this? Huh? I always get lowballed. It's always like 10. No, so it's under 100 lines of Python code. That's including the simulation, right? I mean, so there's code to do the simulation, as well as all the code. I mean, and you just run Bokeh serve on it, and you get this nice sort of updating plot. And again, this is, you can move around and pan, and you can say, hey, I want to start following the data again. If you actually wait long enough, if you move around back here, you can start to see where the data starts to fall off the back, right? So, but you can control that window of how much you want to send. And again, the whole idea is not to send an infinite amount of data. But anyway, so that's a nice example, I think. Yes, those are all under examples app. Yeah, exactly. So I'm in the Bokeh examples app directory. It's maybe kind of hard to see. Let's make this bigger. And you can see there's the OHLC, the selection histogram is there. The spectrogram example that I showed earlier is here. That cross-filter one, here's the clustering one, movies. Oh, line off is new. Let's show this one. There's a custom JS version of this, as well as a other one. This is nice because now it's really easy to sort of control what's on or off, right? I can just click this here. We're actually going to add a function to have interactive legends, so you could just click on the legend, for instance, and turn things on and off. But just a nice, be able to do that very easily. Oh, Fourier animated, this was cool. So someone saw this as a thing online. We thought this would be really cool to reproduce as a Bokeh plot. So this is sort of an example of Fourier synthesis and analysis using Bokeh plot, right? So it just sort of shows, here are the different, the first 4 harmonics individually, and then that's top plot is sort of what they look like when they're added up. And so, again, fun stuff you can do with Bokeh plots. But okay, last thing I wanted to show is the documentation, just to show people where it's at, so you know where to find more information. So we've seen a lot of basic capability. If you really wanted to deploy a site, and you want to have it scale, I mean, if you just want to run it locally, that's great. If you want to share the script with someone to run locally, that's great. If you have a small group, no problem deploying a simple app, it's great. There are more sophisticated use cases. We try to have as much documentation as we can. So you go to this running Bokeh server. One, there's some nice information just about what use case scenarios are really good. There's a couple of other ways to use the Bokeh server too. There is this output server function and Bokeh.Client. I will state that I'm going to be very opinionated and say that writing the apps like we've seen today in the tutorial is probably the absolute preferred way to use the Bokeh server. But there is this client API where you can basically talk to the server from a separate Python process if you really want to. So anyway, we have a lot of information about Bokeh applications, the directory structure that you would need to create. You can add static things. There's a theme.yaml you could add to cut down the code you have to write. You can add a template, a Jinja template as well. And so you can sort of see a lot of things here. What more full-fledged thing might look like if you have models that you want to load, extensions that you have. But there's also some information here on threads, right? So there are considerations if you want to do work in threads. Basically, updating Bokeh models has to happen from the main Tornado IO loop. And so if you want to use threads, there's basically one safe thing you can do from a thread, which is to schedule a callback on the next tick. And so you have to kind of take some care to coordinate things. And you can see an example here of exactly how to do that. If you want to do blocking work in a separate thread, this can show you how to do it. There's also something called unlocked callbacks. I don't want to go into detail, but there's explanation here of what that is. There's also some lifecycle hooks. If you want to have code that runs just when the server's loaded or just when a particular session is created, you can do that. The spectrogram example does this actually. So the spectrogram example has a separate thread that's doing the audio analysis and the Fourier and the power spectrum computation. And it sets that up in one of these lifecycle hooks. And then individual sessions just read from a read-only copy of the current data to update the plot. And so that's why you don't have every session computing that data. There's just one thread computing that data. And there's also information about deployment if you want to do things behind, deploying behind Nginx, right? So there's sort of a sample Nginx config here for doing that. A sample Apache config, if you want to run behind Apache for your thing. If you want to set up reverse proxying with Nginx and SSL, there's an example here as well for a config, as well as load balancing, and then finally a brief discussion of things like supervisor-D. So there's actually the repo that deploys that demo Bokeh site is on GitHub, so you can examine the sort of the full deployment there. That's sort of a fairly sophisticated deployment, and you can look at it. But there you go. Anyway, there's also a numprox, if you want to scale out to more easily. Okay, so I think that's about it. Just wanted to point everyone to where those docs are. Oh, the mailing list is a really good use. Okay, last thing. The mailing list is a really great resource for folks. Because sometimes when we're too slow at figuring things out, we have amazing users and they figure things out too. There have been recent questions about, I want to run a Bokeh server app, but I don't want to run a separate Bokeh server process. I want to run it inside my Flask app somehow. And I was like, well, probably a way to do this. I don't know. I've never tried it. I haven't had time to try it. But you should be able to theoretically just plug in whatever IO loop you want, and someone did it, and they figured it out exactly, and so they actually have a single Flask app here that creates a Tornado IO loop, and let's see if I have it running. And then, yeah, that doesn't run a Bokeh server separately. They call bokehserve.serve with this homemade IO loop that they created inside Flask, and they create this, and let's go to localhost 5667, I think, 5677. Nope, 5667. Nope, okay, what is it? 5567, okay. There we go. And so there's two tabs here, and there's Bokeh server code running, right? Or here he's actually cycling through and updating, just in a very tight loop, updating the values of all of these very quickly. And so just one Flask app running, and there's not a separate Bokeh server. He started a Tornado IO loop directly in Flask, and then passed that IO loop on to Bokeh serve programmatically. So this is sort of cutting edge stuff that it took someone else to figure out how to do. But we have, like I said, terrific users, a terrific community. We're up to about 600, I think, users on our mailing list. And again, 180 contributors, which is amazing. And so please come join us. Help us, yeah.
Was the server updating the data? If you're not looking at it, nothing's going to be rendered, right?
Something like that. I actually have, this is so new, I actually have not had a chance to examine this code in detail. I had to make a few changes to get it to run on OS X instead of Windows, but beyond that, I haven't had a chance to look at it closely. I just sort of ran it and said, wow, that's amazing. Anyway, yeah, so the mailing list is a great resource. We monitor Stack Overflow as best we can as well, but certainly encourage people to come to the mailing list. So, okay, we're just about out of time. Any last questions before we adjourn? Yeah. Oh yeah, 1.0. So we're trying our best to do that in the next, I would say, couple of months. Right now the team is pretty spread thin. We have some client work that people want us to do using Bokeh, and that's an important method of supporting the project. So we have to give that some attention. You know, part of 1.0 is getting in a few things that are just long-standing requests people want, color bars. Hopefully the headless, you know, programmatic saving of SVGs and PNGs, layout work that just went in, things like that. Some of the missing annotations that we didn't have, like, you know, just arrows, simple things that we just never got around to. But the main work of 1.0 is really about locking down APIs. We have a lot of, you know, we have a lot of machinery in our build and continuous integration testing already, but I really want to be able to report out, I want to be able to confidently implement semantic versioning and know exactly that, you know, if something changes, it was not intentional, and I want to be able to report that out very well. And so we have someone currently working on developing some tools to help automate that process and report out, you know, so that we can be completely confident in our semantic versioning starting at 1.0 and going forward, so that, you know, that there's no unintentional API changes. We've been progressively, I think, more strict about that over time. Obviously, when the project was new, we would change whatever we needed to change. We didn't have any users. But now we have users, and so they get annoyed when things change. And so we're trying to get much, much better about that, and I think we've gotten much better about that. But still, I want to be able to have no doubts about API changes. And so implementing that is one of the biggest tasks for 1.0. And then I think, you know, there's certainly lots more to do that we could do, but I think we're in a place where it's stable enough that we can build upon without having to change things. So that's what. So my best guess is a couple of months. I definitely, you know, it sort of depends on the bandwidth of the team and maybe new contributors coming on, but that's sort of, I think, where we're at. So 1.0 is a few months away. Other questions? Okay, well, thanks. Oh, question. Last in the bell. Oh, great question. Okay, last question. Let me actually just show you. So this was written by Ryan Hafen, who is one of the collaborators on the DARPA X Data initiative that sort of initially helped fund Bokeh. It's completely different from Bokeh, right? So there's no reason that the API has to be anything like the Python API. It can be very sort of R specific, and that's exactly what it is. The limitations are entirely dependent on what Ryan has implemented, you know. But he does a really good job. So here's some examples of what he has currently. You know, you can see here's my nice, he calls ly points with this and you know, color equals species. And so he's added stuff kind of like the high level charts thing to automatically do, you know, figuring out what should go in there and generating a legend. Here's one that puts in this regression line. You know, here's a chart that you know, has a histogram. So he implemented a histogram that generates a bokeh plot of that histogram. Here's this periodic table. You know, he sort of customized the tooltip to his liking. Some geo-type stuff. Excuse me, map. You know, maps with bokeh plots overlaid. So again, it's a very, you know, R-specific API. It has nothing to do with the Python API. What it does is it generates, again, the correct JSON. That's all that matters, is that, you know, you have whatever API you want as long as it generates that correct JSON. I don't have a page to link to the Bokeh.Scala, and I actually don't really know Scala, so I wouldn't really be able to comment much on it, but I imagine the Scala API doesn't look very much like the Python API either. But anyway, so these are just a bunch of examples of Bokeh. So this is on hafen.github.io. If you just, you know, Google search for R Bokeh, it should show up as one of the first results. You know, conceptually, it's possible that, you know, maybe someday we could actually have R code drive Bokeh server in some way. Right now, that's sort of beyond the current capabilities, but it would be interesting to see. I think he's actually added quite a bit of stuff here. These all look new to me, so this is pretty cool. Ryan tries to keep up on our releases pretty well. I think he's been integrating the latest 0.12 and 0.12.1 stuff and should have a new release quite soon of that. So anyway, that's there for you if you're using R. It seems pretty cool as well. So. Not yet. We'd like to add some stuff to Bokeh.charts that can do like sort of that auto faceting. And you can certainly write a Bokeh app that does that, but you have to write Python code to sort of do it. There's not like a facet wrap yet, but we'd like to add something like that.
But if we did the grid plot, it would share everything, share the same data.
Yeah. Absolutely. Yeah, there is an example. There is a Python example that's basically identical to this one. It's just you have to sort of set up that grid yourself and set the ranges yourself. No. Yeah. Great. Okay. I think, like I said, last question because we're running out of time. Thank you, everyone, for coming. I hope this has been useful and informative. I hope you had a great first day here at PyData and hope to see anyone and everyone in the next few days here. Please don't hesitate to stop by the Continuum table at the back of this room. I should be there all weekend and looking forward to chatting with anyone who wants to talk Bokeh or anything else. Thanks.